So let me get that added in. Just takes me 2 shakes of a lamb's tail and we're ready to get going. So thank you very much, everybody, for joining us this morning. Thank you very much to the staff. So everyone say thank you to them, because we just, none of this is possible without them. And somebody said this thing is still downloading. That's fine. We're not going to jump straight into the labs right away. We're going to be doing a little bit of just instruction and, oh, cool. We got people in, the labs are firing up. My lab is still working. I think that's my backup lab there. This is the one we want. There we go. So my lab is still working. Cloud labs are still running. Awesome. And once again, thank you for all of you being here. We have some people up on the YouTubes. Zach, how many people do we have on the YouTubes?
We have right now, gotta refresh my screen, sorry. Over 110 right now.
That's nutty. It's fantastic, YouTubers. All right, so if you're on the YouTubes and you would like to gain access to the VMs for this class, you can go here to tinyurl.com, free labs free, and it'll take you to a Google form that'll get you set up so you can get access to the cloud version of the labs. This is one of those things that we've been doing for a while in this course, and we're able to do this because we have somebody who is all in and wants to support us with these endeavors. And I'll explain who our benefactors are here in just a little bit. But there's a large number of people that make this possible and make this successful. And one of the things about making this successful that has been huge is really being able to give people that don't have access to a VM the ability to be able to do these labs, because so many people, they have the technical, let's say they have the aptitude, they have the drive, but trying to get a computer that can be running a series of VMs can be very difficult. And we're going to talk about some of our sponsors a little bit later with not just for the VMs, but also just some people that throw money our way because they don't have to, and they do anyway. And I think that that's just absolutely fantastic. We have some people coming in on the Cloud Labs. I'll take a couple of seconds here to breathe and I will add you all in. So just sit tight and we'll be there. All right. So this is the entry level security class at Black Hills Information Security and Anti-Siphon. You see, at Anti-Siphon originally, Anti-Siphon originally wasn't a thing, because in the beginning it was just Wild West Hacking Fest. We have this conference. You should check it out. It is completely sold out for the in-person tickets, but we still have virtual tickets available. And my class, the Introduction to Pen Testing, is still available virtual, and you get access to the class and you get access to a bunch of the talks at Wild West Hacking Fest. So if we could get a link up for Wild West Hacking Fest virtual, but also some of you want to learn pen testing. I have a 2-day class. We'll talk about penetration testing. So check those things out as well. But during COVID, some weird things happened. Like the obvious things, like, a million people dying. But the weird thing that happens, and we had to cancel Wild West Hacking Fest, and we had to lift the entire conference to a virtual conference basically in 2 days. And the team was able to do that. They pulled it down. It was awesome. It was so cool. It went very, very well, even though there was a lot of people missing out on sleep and important things like that. But it went live, and all of our trainings went virtual, and they all worked. So Valda and myself and Erica, we sat around and we were like, we could literally do more virtual training on a regular basis. So we started doing more and more virtual training. And eventually we realized we had something here when we did our first Pay What You Can class. Our first Pay What You Can class, I think it was cyber deception. And everybody liked cyber deception, but there were people that were like, hey, you need a general security class. So we created Intro to Security. Then we had people say the Intro to Security class is great. Some people don't even know what a command prompt is. They don't even know how to use Linux. They don't understand networking. So we created this class, the SOC Core Skills class. This class is designed for people to have the basic understanding of operating systems and networking to be able to work in a security operations center. So yeah, we are absolutely going to be doing Intro to Windows. We are going to be doing Linux, TCP/IP, basics and fundamentals. These are the core things that everybody needs to know in the world of computer security. Now, there are absolutely courses out there that we'll go through and we'll attempt to teach you a whole bunch of things you honestly don't need to know in the world of computer security. Like they'll say, oh, well, we're going to teach you a bunch of security models like Bell LaPadula, Clark Wilson, all these different models of security and Biba. And no, you honestly don't need to know that shit. Learning crypto. Do you have to know crypto inside out and backwards? Like, do you have to know AES? What is a stream cipher? What is a block cipher? What are the different modes for a block cipher utilizing AES? What's the difference between electronic codebook mode and chaining block mode? Those are all really cool things. Don't get me wrong. You should learn them, but do you need to know them as somebody that's just getting started in computer security? No, nay, I say. Nay, you do not need to know those things. So we wanted to boil it down to, yes, somebody said CISSP stuff. Kinda, I guess. Suppose. By the way, I'm not going to rip on the CISSP. There are very few certifications in the world that are accessible to people that just have the experience, and the price is there. The price is absolutely there as well. All right. So we want to focus on the things that's all killer, no filler, from people that have been doing this for a long, long, long time in the community. And there is some overlap. There is some overlap between the SOC core skills class and the InfoSec class, and there's even a little bit with cyber deception. But generally, when you're looking at the kind of process for taking these courses, you would take SOC core skills, you would move into the intro to security class, then you would do cyber deception. And hopefully at that point, you have a good idea about what things in computer security call out to you and what things in computer security like really kind of make you shine on the inside as well. So yeah, we do have kind of a progression chain for these courses for people to kind of work through them as well. Now, do I cover absolutely everything in this? No, I really don't. I have this presentation. It's the 5-year plan, okay? And this 5-year plan for information security is really kind of taking and expanding. Like, I recommend you learn coding. When we're talking about SOC core skills, it's straight up, what do you need to get that job in computer security? And to be sure, we're going to have Jason Blanchard come in a little bit later on this week, and he's going to talk about how you job hunt out there. Has anyone taken Jason Blanchard's job hunting webcast? Let's go ahead and type that in. If you have, I would love to know about it. Because here's the problem, and it is, in fact, a big problem in the industry. So many people think that in order to hunt for a job, it's all about having the right resume. Like if you have a cool resume, then immediately you're going to get employment, and it's going to be wonderful, and it's going to be great. That's not how it works, folks. It isn't how it works at all. Seriously, if you're trying to get hired in the world of computer security, what you have to do is a lot of social engineering and really tuning your resume to get to exactly what that organization is looking for. And Jason has an amazing webcast that walks you through how to go about doing that. So you need to check it out. Jason Blanchard, he's also known as Banjo Crashland. If somebody could get a link, we have a copy of it on the YouTubes that you can look at right there. We already got it. Bang, bang, nailed it. And you can check out that whole thing, but he's going to come on and he's going to do it during some of our sessions this week as well. I love that meme. We're looking for someone 22 to 26 with 30 years of experience. By the way, I may get you guys, let me see, hold on. I may throw up a form, and to the first X number of people, we'll ship out free t-shirts. How does that sound? Do you guys want a free anti-siphon t-shirt? Somebody was talking about free t-shirts. I might make that happen. I can do that. I own the company. And I have some cool shirts that I can get you all. But here's the deal. If I send you a cool shirt, it's got to be like a marketing propaganda thing. You guys are going to have to take a picture and post it. I don't care if you post it to your friends, like on text messages or Snapchat or the WeTubes or the Xtraders, whatever. I don't care. But we'll send you a shirt. And no, I'm not going to hold you to it. I'm not going to hunt you down and be like, we had an agreement. Be like InfoSec Batman. Fear me. All right. So at any rate, 5-year plan is another webcast that goes through how to expand on these things that we are discussing and going through how do you learn operating systems? How do you learn actual hacking? How do you learn penetration testing and things of that nature? All right. So for this course, I kind of want to set the mental model, like if we're going to be working in the SOC, because like I said, I get a little bit frustrated with some computer security classes because they get into stupid things, like we're going to learn crypto and we're going to learn security models. And I no, you'll never use those things again. That's bullshit. So everything that we're going to be doing in this course, we're going to be working through the lens of, are you compromised, right? We're going to be looking at it from a Windows perspective, from a Linux perspective. We're going to be working through it from a perspective on network, like how do we actually go through the network traffic as well. So we will be running through these things and setting it up so that you have that mindset. Because once again, there's also security classes out there which are actually hot garbage that are like, we're going to teach you Windows. Everyone open up a command prompt. dir lists out directories and files. And it's not impactful in a way that it's teaching you how to do something that will assist you in an actual job. So we're going to be looking at everything through the lens of, so you're compromised. Now what, right? If we're looking at a compromise in networking, if we're looking at a compromise from the perspective of Windows and Linux, we're going to be looking at looking at it through that lens. But let's talk about why I want to do it this way. First thing is, it's a pedagogical device. So if you actually want to teach people, and I've been teaching people a long time, I'm very old, Brian, very old. I am ancient in the world of teaching computer security. Pedagogical devices are basically learning tools. How do we help people understand and learn something in such a way that it's sticky, that it becomes something that is part of their psychological DNA? Well, first steps whenever we're working through an incident are incredibly difficult. And when you're trying to work in a SOC job, security operations center job, your day-to-day, maybe doing some user management and maybe doing some security management, some light vulnerability analysis, which we're going to have here as well. We're really going to be in a situation at some point where the shit hits the fan. And all of a sudden you have an incident, you have really bad things happening. And now what are you going to do to deal with that incident? And that's what we're going to be focusing on in this class as well. All right. So mistakes and paralysis, we need to keep moving. We need to keep going. We need to have a plan, but we need to have a plan in such a way that it makes sense, because this makes no sense. A long time ago in a galaxy far away, I was working at Northrop Grumman, and we were working on a classified project, something with, I don't know, satellites, just say. No, that's not fun. Let's do dead aliens, huh? Kids like dead aliens. We're going to stick with dead aliens. So we're working on a dead aliens project in a highly classified secure area. And this guy came up with this flow chart showing the IBM identity and access management suite of tools. They had, we were going to use IBM identity and access management. And I found out that identity was a product and access management was a completely separate product. You had to pay for them separately. And neither of them worked without the other, because IBMs, right? Just, yeah. So he puts up this chart, and it's very clear while this dude is presenting, he has no clue what he is doing, like none at all, just completely and utterly confused. He gets to this slide that shows the process flow for identity and access management on the back end, and it looks like this slide. It's just the spaghetti mess of boxes and all these little decision points. And he looks at it, he looks back at us, and he looks at it again and goes, yeah, I think this is pretty much self-explanatory, and just goes to the right to the next slide. No idea at all what the hell anything was, but he did have a PhD, which was pretty impressive, actually. But this is horrible. And this is the way so much incident response is handled in organizations. They'll come up with these really complicated flow charts that have all these different decision points, and it doesn't work. It doesn't work. You look at these flow charts, you go through all these flow charts, and no one's got time for this. Like, you can't. This is a waste of time. You're not going to do anything with that. It's just crazy. Also at that same job, a similar thing, kind of working from an IR perspective. When I first got my clearance, I was on the bench for about I don't know, I want to say 3 months waiting for my clearance to come through. That's where I'm like employed, making money, but not actually working for 3 months, which sounds great, but it was just miserable for me. It was like probably professionally some of the most miserable times of my entire life. Finally, I get my clearance and I'm expecting to go into a secure facility and I'm expecting to be like 24 Jack Bauer or, CIS, really cool computers, great lighting. And it was just a dirtier cube farm, honestly. And they took me in and they're like, computer security guy coming in. We're going to have him work on the IR procedures. So they take me into this back room and they introduce me to Bill. And the first thing that I noticed about Bill is that he should be dead. Like Bill shouldn't be a living person. Like he looks like the personification of a mummy that didn't get the memo, right? He's just like, and they're like, John, this is Bill. And I look down at Bill, and Bill looks at me and he says, kill me. And I'm like, oh my God, this guy is in rough shape. So they're like, John, you're going to be working with Bill on the IR procedures. I'm like, can I see the existing IR procedures? And he's like, and he pulls up this tome. It's like 700 pages long. It's this monster like thing of papers. And he drops it on the table. I start going through it, and it's literally how to handle every single major virus that has come out in the past 6 months. Every single major virus. So it's almost like management came in and they're like, yeah, Bill, we're going to need you to write up some IR procedures for the SQL Spida A26B2 variant. It cracked the McAfee top 25. I think we're going to want to have documented proof on how to handle that particular one. That'd be great. Thanks. And that's what he had been doing. That was Bill's life, right? So I'm going through all of this and I'm like, Bill, how old are you? And Bill's like, I'm an intern. I'm 23. So they sucked Bill's life away. Bill lost his entire life because of overly documented policies and procedures. Don't be like Bill, okay? Don't let that happen to you. Don't let that happen. Instead, what I want you to think about, because I get people that get all worked up and they get offended because they've been to a bunch of security classes and their corporation injected a bunch of money and time into developing procedures that are stupid in the flowchart perspective. And they're like, well, Mr. Smarty Pants, how do you recommend we do it? Excellent question. Instead of thinking in flowcharts, I want you to think in Legos, because Legos are a lot more fun unless you step on them. But to be honest, stepping on spaghetti ain't fun either. I don't know. You'd have to choose which one you'd want to go with, stepping on Legos or stepping on spaghetti. I personally don't judge, but both are weird. You shouldn't be stepping on either of these things. However, moving along. So instead, I want you to think of Lego blocks of functionality. And you remember in the Lego movie, Elliot and all the other characters, which is actually an amazing movie. The Lego movie is phenomenal. They would encounter a problem, and then based on the Lego blocks that were around them, they would solve that problem, right? They would go through and solve that problem based on what they had at their disposal. And that's what I want you to do. I want you to think of Lego bricks of functionality, Lego bricks of skills that you should have in IT that'll help you deal with an incident. These are those Legos. All right. So these are the things we're going to be doing in class. Endpoint analysis. We're going to be talking about that. NetFlow, Zeek analysis, user entity behavioral analytics, isolation, endpoint protection analysis, server analysis, internal segmentation. These are a lot of the things that we will be discussing in SOC core skills and also in the intro to security class as well. So we'll be building this up and you'll be able to see it. By the way, this is all from a game, Backdoors and Breaches, and you can play Backdoors and Breaches at play.backdoorsandbreaches.com, where I'm going to post this up here. Oops, because everything is awesome. Like, it brings back childhood memories. Yeah, my kids. All right. So these are great. You can actually get them in the Spearfish General Store, the actual physical copies that happen to look a lot like this. New game smell. Look, look, look. This one's still in the wrappers. This one's still in the wrappers. Mm, smells like a factory in Szechuan. But yeah, this is the game. And you can get it at the Spearfish General Store. Somebody can drop a link where they can get Backdoors and Breaches. That would be super cool. But you can also play it online for free. So I know that that sucks at capitalism. It does. Brian just shared that link out there. I'm not going to do a magic trick. I don't know any magic tricks. But these are the different expansion decks. And whenever you choose a deck, it automatically creates a scenario, a hack. So like initial attack and compromise, new service modification, domain fronting. And if I refresh this, it's going to create a new attack with new exploits. And if I refresh it, it brings up another attack with new exploits. This is crazy. And every one of these has full links and descriptions of what that particular attack actually is as well. And then down here, each of these blue cards is the card that flips over the attacker's cards. So cyber deception, got a whole class on that card. Whole class on cyber deception. Endpoint analysis, we're going to talk about Windows and Linux endpoint analysis. We're talking about network traffic analysis right here. We're going to be doing a lab with Rita and AC Hunter Community Edition. So we have all of these things set up and ready to go, and you can play it online. Full instructions, of course, you can go to the Backdoors and Breaches website and learn how to play. So a lot of this class is built around the concepts of these IR Legos, because you can use these combinations of endpoint analysis, endpoint protection analysis. You can use these combinations to be able to deal with almost any incident. But these also become discrete areas of skill that you need to have as an information security professional that'll help launch your career and be a lot more effective. So we'll be dealing with that as well. The other thing that I like to do is I like to point out to people that you really, really, really shouldn't panic, because panicking is bad, okay? And it's weird because usually whenever people encounter something that they've never encountered before, their brain like just craps all over them. How many of you have ever encountered something you've never seen before and immediately you seize up? You cannot think, right? You cannot think. And in computer security, in the world of just computers in general, this happens all of the time, where we have people that encounter an error, they encounter a thing, and all of a sudden it's like their brain is like, you've never seen this before, you're a moron. Ah. Don't trust your brain. Your brain's an asshole. You can do better. So we're going to be talking about what are the things that'll help you prevent yourself from panicking. And one of the first and most important things that you're going to have to do to prevent that level of panicking is practice. Whenever you encounter something for the first time, it is important that you kind of work through the problem. But the best way to deal with that is don't encounter a problem for the first time. Like, try to practice it, right? Like, if you want to learn how to detect malware on a Windows system, I'm just throwing this out there. How about you infect your computer with some malware and help get it off? Or maybe, just maybe, one of the things you could do is pick up the phone, talk to your grandma, and finally help her remove malware from her computer. Would it kill you? Huh? Would it kill you to sit down and work with Mima and help her get a malware off her computer? Sure, I know. As soon as you get it off, she's automatically going to click on some software update and get reinfected again, but it's good practice. And it's much, much, much better than the socks that grandma gets you. Grandma's giving you experience. And that should be on your resume, right? So practice makes perfect. Makes it to the point where we don't freak out. And that's ultimately what we're going to be working on. And also with these labs, you can redo them as much as you want. The VMs are out there. They're freaking free. Like, I don't even lock down my GitHub repository, guys. Like seriously, you got all these people that get so worked up over making money on this stuff. Like, as big as Strand, JS, Intro Labs. These are my labs. They're free. You can do them at any time. Like, I'm not charging for this. And yes, in case you're curious, this is every bit as good as the SANS Institute provides. Yes, and it costs you nothing. This is literally the best that information security training can offer at no cost. So you have absolutely no reason not to go through and practice these things as much as you possibly can. But we're going to start with networking. Okay. We're going to start with networking because people don't understand how computers work. Like they just don't understand how it works at all. They don't understand how the magical bits and bytes go across the network. They don't understand what the concept of a byte is. They don't understand the concept of bits and then nibbles. And if you take a bunch of nibbles, you put them together in a packet. That's how NutraSuite is made, folks. But we're going to be going through and we're going to be talking about how networking actually works. And when you're learning networking, like seriously, what is like the first thing when people are teaching you the network stack? Like, what is one of the first things that they teach you in networking? Oh, yeah, the OSI model, Open Systems Interconnect model. What a load of garbage. The OSI model, by the way, if you have ever learned the OSI model is a lie. You will not be learning that here, okay? Because it's not real. The OSI model is the InfoSec equivalent of Santa Claus. Everyone talks about it. We all pretend it's there, right? But it's not real. And sorry if you're here and you're just finding out that Santa's not real. I'm sorry. I'm sorry. Yeah, TCP/IP is wench. It is real, absolutely. But the OSI model ain't. And by the time we get done with this section, I'll prove it to you. Okay. All right. So just sit tight. So if you're all like, I spent a lot of time investing into the OSI model, and now he's telling me I don't have to know it. I'm reticent to this entire thing. Sit tight. You'll learn. Buckle up. All right, so let's jump in. We're going to start with TCP/IP. It's a very good place to start because when packets are born, this is what they look like. All right, so I'm cutting off the 802.2 header. We aren't going to get into layer 2 stuff too much because you don't really use it all that much unless you're hacking, right? Unless you're hacking, SANS training is great, but it's very expensive. Yes, I know. And yeah, this is like, if you want to know what like the top shelf SANS training is, this is what it's like, but free. All right. So let's go through. Let's start with the IP header. All right. So the IP header is, let's do something different. All right. So whenever I send an envelope to you, like I'm going to send you all t-shirts until I run out of those t-shirts. Whenever I'm shipping t-shirts to you, what do I have to have on the outside of the package to get that t-shirt to you? I need to have an address. Excellent. What is made up on that address? What is on that address? Like what makes up an address to get it from me to you? What are the concepts of an address? The street name. Street name, great. What else? Name, zip code, city, state. All right, awesome. So if you look at that envelope, it goes from a very coarse perspective, like the state is South Dakota. Then it moves to a zip code, 577 like 85. Then it gets to a city, Rapid or wherever. Then it gets to a street, and then it gets to an actual number address on that street. We work from big to much smaller. Okay. So when we're looking at an IP address, we're looking at an address that is usually IPv4. We can talk a little bit about IPv6 as well. No, we're not going to, if you guys want to buy the hats, you can. Where is my hacker hat? My Rekka hat? If Zach could pop on, Zach's got his on. He can show you and he can fashion model that Rekka hat. We have an IP address. All right. So that IP address is what we call a dotted quad. Like you'll look at it, it'll be like 4.92.156.12, right? So that would be a dotted quad that represents the IP address. And that generally goes from a level of coarseness down to very specific. And that gets into subnetting and what is the network segment and what is the host segment. But we get ahead of ourselves a little bit. Let's break down how those IP addresses actually work in the real world. So let's quick to the internet. So on the internet, there's these ASN lists that you can download. And these are autonomous like systems list. So they're the numbers. And this gives us an ASN number, okay? And it gives who's responsible for that number, all right? Okay, so these are the ASN numbers that are out there. Now, the important thing to think about is take all of these IPv4 addresses, all right? There's 32 bits that represent the dotted quad. How many possible values are there for 32 bits? So if I have 32 bits, how many possible values are there in 32 bits? The Wanderer said, are these ISPs? They are. Roughly 4.2 billion and change, all right? So there's 4.2 billion IPv4 addresses that are out there, okay? Now those addresses are broken up into ISP responsibilities, right? So these ASN numbers, 11 goes to Harvard, right? What is this one? National Aeronautics and Space Administration gets number 41. I'm going to see if I can download. All right. Because if you actually look at this, oh, that's awesome. Let's go here. Let's go to the raw content. There we go. So these are the ASNs, and these are the organizations that are responsible for them. I want you to think of these like zip codes, okay? You have all of these numbers, and these numbers have IP address ranges associated with them, okay? So these numbers are set up that you can dump all of these. Trying to find a good one. This one's tab separated. I'll do that one. Let that download, because the ones that I'm finding don't have the IP ranges in them, but those IP ranges are like zip codes of responsibility, and they're ISPs. And there's a lot of them. There is a tremendous number of these. And this also is how routing happens. And it's also how babies are made. Maybe not babies. Open with. That is not what I want. Numbers, sure, what the hell. Close that down. That's a big list. So we have these zip codes. Yeah, IPv6, we aren't going to run out of IP addresses anytime soon with IPv6. Boy, that's a big database. All right, so we'll come back to that. But let's go back to this. So when we look at an envelope, right, we have that header information or the address information. We have the address information of the zip code, the city, the state, the street, the name, okay? We have similar information on TCP IP headers as well. So if we look at this IP header, we have the version. The predominant version that is used today is version 4 or IPv4. You also see IPv6. We also have something that breaks down what is the header length, what is the type of service, what is the total length. And then we get into this like this identification field. All right. So identification, it actually goes way, way, way back. So back whenever the internet first got started, the first time the internet ever was released, according to DARPA, by DARPA, was at the Hilton on Connecticut Street in Washington, D.C., in this beautiful ballroom that looks like a spaceship. And they released it there, and that was kind of the beginning of the internet. But back then, and even moving forward through the 80s and the early 90s, whenever you were routing packets, discrete little bits of information that we send back and forth, like envelopes, sticking with that analogy, sometimes some of the routers that were routing those packets couldn't take certain size. Their maximum transmitted unit size was smaller. So they would have to fragment a packet. So they'd have to take that big packet and break it up into baby packets, because I told you that's how baby packets are made, right? So we're going to take this big packet, break it up into baby packets. When you take a big packet and you break it down to baby packets, every one of the babies has the exact same identification number. They all have the exact same identification number, okay? So we have that same ID. Now, if you look, that's half of 32. So anything that goes all the way across, like if we look at a source address, it's a 32-bit number. We look at the destination address, 32-bit number. If we look at identification, it is a 16-bit number, right? That means there's 65,536 possible IP ID values, and that's fine for IP ID. Works great, because every single small baby packet is going to have the same IP ID, so that whenever they reassemble, it knows that these packets hang together like a nice rug, All right. The next little one over is we have the IP flags. The IP flags. We have X. That's weird. And we have don't fragment and more fragment. Don't fragment is exactly what it says on the tin. Just don't fragment this packet. More fragment says there's more fragments yet to come. When the last fragment is there, it doesn't have that set. That means the operating system knows that that is the last fragment and it can start reassembling. And then we have fragmentation offset. So as you're reassembling these packets, it tells you how many bits from 0 you need to go to place this packet so it sticks together with the rest of the packets. But I want to talk a little bit about that X. We're going to talk a little bit about that X because X is going to give it to you. I can't get through this class without a DMX reference. I don't know why, but at any rate, we have that X. Does anybody know what that bit is called? What is that bit? And now we're on the DMX memes. So what is that bit called? It's just one bit. It is called the evil bit. Okay, it's called the evil bit. Now, according to the RFCs, and I'm going to get into what RFCs are here in just a little bit. According to the RFCs, that bit, the evil bit, as written by Steve Belvin, is the bit that hackers need to flip to 1 so that everyone knows that this is an evil packet with an hack attack inside of it. So the attackers will have to flip that bit to 1 so that we know that this is an evil packet with evil intent and evil designs so that we can easily filter out the evil packets off the network. Now, some of you are like, that seems really weird, and it is, but it introduces a couple of concepts that I think are pretty fantastic. The first thing it brings up is the idea of RFCs, requests for comment. Okay. So request for comment, look at the date, folks. What's the date, ladies and gentlemen? What's the date? Requests for comment are how the internet was built. Okay. So if you want to learn anything about IP ID, you want to learn anything about a header field, anything at all, you can look up IP ID RFC. And there's an RFC that describes how the IP header is supposed to work. Okay. Steve Belvin released one in 2003 on April 1st called the Evil Bit Security Flag. And it was a April 1st troll and it got people, right? This is one of the first internet trolls. And there were a number of people that were like, Steve, that is the dumbest thing I've ever heard. What makes you think an attacker is ever going to set that bit to 1 so that, you know, it's just not how that, it was trolling the internet. Got him. The other one is we have the IP over carrier pigeon. That's another one. A lot of people don't understand this, but IP over carrier pigeon has been tested. It does in fact work. And it's also susceptible to many of the exact same types of attacks that general packets encounter. For example, if you're trying to do IP over carrier pigeon, over hunting season, you're liable to drop a few packets, and that's bad. And what do you call a carrier pigeon in a blender? Packet fragmentation. Reassembly is very, very difficult. All right, so the reason why I went through all of that is I wanted you all to know that there's something called requests for comment. And these requests for comment are not just jokes. They are literally explaining how the internet works. RFC 793 describes how a TCP IP three-way handshake works. It doesn't mention a three-way handshake anywhere. It describes four-way handshake. That's a whole nother series of things that we need to discuss later. But the point is, that's how this stuff works. So there's literal RFCs that describe all of this. There is a time to live, a time to die, a time to learn, and a time to cry. But in this particular situation, packets have a time to live. This is a reverse counter. I'm going to talk about Algora and the internet a little bit later, but we're going to go over TTL, but it's a reverse counter. It starts at a number and it counts backwards. And as soon as it gets to 0, whatever routing hop sees that get to 0, sends it back and says TTL exceeded. We have the protocol, the header checksum. We get that source address. That is the number. That is the number. And I got that thing open now. So if we look at those numbers right here, now we have the actual numbers and we have what are the IP ranges that they're responsible for. So you can see that Cloudflare right here is responsible for 1.1.1.0 to 1.1.1 through 255. So it's saying these are the ranges that these IP addresses are in fact responsible for. So that's how things get routed on the internet, right? With some hand waving and some magic that happens in there as well. Now, when you're looking at a source address, it is a number. It is a number. It is not google.com. It is not yahoo.com. It is not facebook.com. It is a number. When you're routing packets on the internet, they do not know what google.com is. They just don't at all. The only thing that they know is it's routing to a number. We'll talk about DNS and how all that stuff works a little bit later, but we'll have the source and the destination IP addresses we'll discuss. You also have IP options like loose source routing and strict source routing and things of that nature, which we don't use much anymore. Now the TCP header. So these headers, they go like this, right? So you're going to have the IP header, and then if it's a TCP packet, there will be a TCP header right below it. All right. And if you have like network, like layer 2, it'll be 802.2. So you'll have these headers and they stack on top of each other. Each header is data for the header above it. So if you're looking down here where it says you have the IP header, below this is data, and the data for IP is the TCP header. So we're talking about a protocol at this point. So IP gets us to the proper location on the internet, right? Gets us to that IP address, gets us where we need to go. Now, the TCP header is dealing with the ports and services on a computer, all right? So I want you to think of two buildings for me, all right? Two buildings. Both of these buildings have 65,536 rooms. Think of them as hotels, really large hotels. If I'm sending something to you from one hotel tower to another hotel tower, I will have to say what room that needs to be routed to. So I could send you a package. I would have zip code, the state, the address, and then I could also say room number, and it would get to that building, and then someone at that building would take that packet to that room that you're at. Right? So those are called ports. There are 65,536 ports for TCP, and there are 65,536 ports for UDP. And I'll talk about the differences between those two things as well. Yes, we do potty breaks at the top of every hour. Okay. So we have these ports, and we know that there's 65,536 because each of these fields are 16 bits long. You can see, right? Source port, destination port, right? Now, whenever I'm sending packages, if I'm sending packages to a room and a bunch of people are sending packages to the room, how do I keep all those packages separate? Well, we can work with sequence numbers, all right? Sequence numbers. Sequence numbers are 32-bit numbers. So if you have a web server, let's say let's go to Google, right? Like that. Nope, I did not want to do that. Thank you for helping out. So I'm going to Google. No. There we go. So here we are. We're at Google. Apparently, I'm now in the UK. So I'm going to stay signed out. So, man, this is awesome. The instructor of the class can't get to a regular goddamn Google page. All right. So with all of this, if we all go to Google, how the hell does Google, at a networking perspective, keep all of our Googling separate? Because that's a lot of Googling. That's a lot of Googles. We could use a program like Tracer T. I'm sorry, Next Gen Hacker 101 joke. But we have a bunch of people that are using Google. How does it keep them all separated? Because we're going with offspring references, got to keep them separated. At the network level, it's going to use sequence numbers. All right. At the network level, it's going to use sequence numbers. All right. Now, those sequence numbers are 32-bit random, pseudo-random numbers that are generated that lets Google know at a network stack perspective that I'm communicating with Google, and you're communicating with Google, and they're communicating with Google, and they're communicating with Google. Yay! Everyone's communicating with the Google, right? So we use those numbers to keep these communications separate because you have a computer that's going to be communicating with hundreds, if not thousands, of other computer systems out there as well. Then we have the offset. Then we get with the reserved bits, and we have those flags that are reserved as well. Congestion control, ECW, explicit congestion notification. But then we get into the UAPRSF, urgent, ACK, push, reset, SYN, and FIN. These flags tell us at what point in the communication we're in. So if it's urge, it says there's an urgent data set within this packet that needs to be processed immediately. And then it'll go to the urgent pointer, go to the offset, and immediately load that data irrespective of the window size. Don't worry about that. That's trivia. That shit's never going to come up again in the rest of your life. It can't hurt you. It can't hurt you. It's okay. It's okay. It's okay. Then we get into acknowledgement. You have to know what acknowledgement is. Because when we're communicating with the three-way handshake, we have ACK packets. And I'm going to get to ACK packets here a little bit later. But with ACK packets, we're constantly acknowledging what has been sent and received. So if I send a sequence number to you, you will acknowledge that you have received that sequence number by incrementing either by 1 or the number of bytes that were received associated with that. Push means that, once again, you're going to push it directly into the application stack. Reset means something went wrong. Reset the whole connection. Let's start over from scratch. SYN means we're doing a synchronization request. We're starting communication. And then FIN means that's it. That's the end of the packet. We're done. That's the end of the payload. That's it. We're done. Window size, it's dependent on the operating system, but basically that's the amount of data that can be received by the operating system, held in the buffer before it's flushed into the application. Checksum is a CRC32 checksum. Just says, hey, the packet has integrity, good to go. And then the urgent pointer I talked about there as well. And then we have some various options too. This is different than UDP, right? So if you're looking at TCP, when they developed TCP in DARPA, they developed TCP in such a way that they wanted to ensure that packets could travel and there would be integrity in communication, even in the event of a nuclear holocaust. See, the thought is, if you're sending packets across the United States, and Kansas and Nebraska are nuclear wastelands, in South Dakota too, if the packets are going across those areas, there's going to be a lot of radiation. And if there's a lot of radiation, that means that there's going to be decay in the packets. And we need to make sure that those packets are sent and received and the integrity is valid. That's why they created TCP/IP the way that it is. The thing that they didn't understand is copper freaking melts in a nuclear holocaust, people. Like, good. Like a whole bunch of people sitting around, they're like, well, you know, radiation might interfere with the copper wiring. That isn't there because everybody's dead. And at any rate, they were really, really worried about sequence and acknowledgement and receipt and integrity and all that stuff. With UDP, they're like, F it. I don't care. I don't want any of those things. We have source port, destination port, length, checksum, effing send that out. Just get it out there as quickly as possible. Now, does that mean that UDP is worse than TCP? Doesn't mean it's worse. No, it's just different. What types of applications would be better for UDP? What would be a better, I think, videos, right? Streaming audio, streaming video. If you drop a few packets, who cares? What's a few packets between friends? It may glitch for a second, but it's going to continue to work and it's going to continue to run just fine. All right, so now we're going to talk about the TCP/IP three-way handshake. All right, and for us to do this, let's quickly go to VM. There we go. Let me get logged back into my VM here because I want to actually show you this stuff. All right, so I'm going to open up 2 command prompts, Ubuntu 1, and we'll do Ubuntu 2. There we go. So we're splitting the tab. And then I'm going to open up a 3rd Ubuntu prompt because that's just the kind of crazy we're doing here. And I'm going to become root. All right. And I'm going to do TCPdump. And we're going to do Ethernet interface ETH0. Oh, no. That wasn't what I wanted. I wanted local loop back. Let's go ahead and do LO. Here we go. All right. So I've got a sniffer running. So now I'm going to go netcat. I'm going to listen on port 2222. Then I'm going to connect to 127.0.0.1 on port 2222, and we're going to make a connection. All right. So now we've made that connection and we have some packets that have been sent. All right. So if we're looking at this, we have the date timestamp in our sniffer. It said it saw an IP packet and it came from localhost at the source port. So we're looking at the things associated with the TCP IP header. It went to localhost on port 2222 because that is the dumbest thing I have ever done. Oh no, it's not that dumb. Not that dumb. I've done dumber things. Sorry. Way dumber things. Like crazy dumb things, but we won't talk about it. But that's our port. We have a flag is a SYN packet. And that means we're starting up new communication. We have a sequence number, which is a 32-bit number, right? A randomized 32-bit number. We have the window size, 65,495. We have our options from our header information. The length is 0. All right. So this right here makes up our first packet that is a SYN packet from ourself to ourself. Okay. Right there. The next packet, looking at this date timestamp, is the response. Do you see how this goes from port 53176 to port 2222? Do you see that there? Right there? All right. If you look, this next packet is reverse because crisscross is going to make you jump. So we have the packet originating from port 2222. So you always see that kind of crisscross. You have the source port, the destination port, the response, it flips. The source port becomes the destination port, and the destination port becomes the source port. So they're going back and forth. Now, let's look at that packet. We're going from port 2222 right back to the same port that it came from, right here. We have the flags, we have the SYN flag in conjunction with an ACK flag. So we're starting a brand new sequence number from scratch, but look at this acknowledgement number. Does anyone see anything special about this acknowledgement number vis-a-vis the packet above? What do you see there? Take a look at that acknowledgement number. Very good. It's incremented by 1. It's incremented by 1. So that's how we acknowledge that first packet. We acknowledge it by incrementing it by 1. But we start a new sequence number all over again. Now, after these two packets, everything becomes ACK packets. So we've got SYN, SYN-ACK, and then ACK. And then we have in this situation, we have a FIN and then a FIN-ACK as well. All right. But everything goes one, like just acknowledgement after that. So that's how these packets are sent. We have a SYN packet. We have a SYN-ACK packet. Then we communicate through a series of ACKs where we acknowledge the previous packets that were sent by basically increasing that acknowledgement number by the number of bytes or the data size that was received. So it's a way that we can make sure that we have integrity in this communication. I saw somebody had the Integrity Farms logo. That's absolutely right. And there it goes. And then we have Mars attacks. So if you look at this, we have SYN, SYN-ACK, ACK, 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 ACK. I am convinced that Mars attacks is an in-depth introspection of the TCP IP three-way handshake. That somewhere on the cutting room floor, Tim Burton has an edit where a baby Martian comes into the world, looks up at its mom and says, SYN. The mom says, SYN-ACK. It communicates through a series of ACKs until the day it dies, at which point it would say what? What would be the last thing that Martian would ever say? FIN. But we never saw that because their heads exploded due to country music. All right. So whenever we're looking at these packets, when we're looking at these different things, we have to we don't want to boil the ocean and learn every single port and every single service that's out there because there's a lot of them. A lot of them. So we're going to take a look at a few different views of the internet and what are the main ports that are out there today. First one comes from Fyodor. Fyodor is the author of Nmap, and we are going to be using Nmap heavily in this class. But Nmap is a tool that identifies which of these ports are open and which of these are closed. And according to Fyodor, these are the top 10 ports that Nmap sees. 80 is for web traffic. 23 is Telnet. 22 is SSH. 3389 is terminal services. 445 is data services. 139 net BIOS. 21 is FTP. RPC is 135 and 25 is SMTP for mail. So if you want to have like a basic understanding when you go and you hit up that job interview, trying to make sure that you're not going to come across looking like you have no idea what you're talking about whatsoever, these are going to be the ports that you're going to want to know the services associated with them. And even a lot of the most seasoned people in the world of computers honestly don't know all these ports. Computer security people tend to know them a little bit better, just simply due to the fact that we're constantly doing vulnerability analysis and like pen tests and scanning of these ports. So we see them quite regularly. But this is the Nmap view of the universe. Shodan's view of the universe is different. All right. So let me show you Shodan and what it does. Let me go to Shodan. Show enough. Although I'm pretty sure that Shodan, his name is based off of what is the name of the game where Shodan's is it a System Shock? I might have that wrong. All right, so I'm logged in. So I can do a search for, let's say, MongoDB. If I do a search for MongoDB, it's going to come back with all the Mongo database instances in the world, right? So we have 101,000 exposed Mongo databases on the internet right now, right? So these are all databases and it's identifying them based on their ports and also their banners. If I click on one that's compromised, oh, I'm not an enterprise user. I thought I was an enterprise user. Huh. You can see how many of these Mongo databases are compromised. So if I go back here, right here, this one has been compromised and it knows that because of the banner has shifted on it as well. I can also do a search for JetDirect and I can find a whole bunch of JetDirect printers that are plugged into the entire internet. We have 5,448 printers just plugged right in, just right into the internet, just no protection, no firewalls, just right there, just sitting there on the internet. Bad things, a lot of bad things. All right. So those are JetDirect printers. I can also look for Chuck Norris. Because Chuck Norris is on the internet right here. Chuck Norris fears nothing that is not Emily, does not need a DNS server. He knows all the IP addresses by heart. What else do we have? Oh, those are the Chuck Norris quotes that we have. It's protected by Chuck Norris himself. Great. These are banners. So when you look at different services, there's banners that identify those services. Generally, as a human, you don't see these banners. But whenever there's communication between a browser and a web server, it'll be basing things based on that banner. But wait, it gets worse. So if I go to images.shodan.io, by the way, what I'm doing at this point, I am off-roading. Okay? It's entirely possible that something potentially bad may show up on the internet as I'm doing a live demo, because that happens. So you may want to have your kids leave the room right now. I don't know what's going to happen, but it might get interesting. All right, so I can put in ports here, and this is a VNC port. And these are a bunch of terminals. Oh, wow, we got My Little Ponies. That's good. That's what I needed. My Little Ponies. But I can get a little bit more specific. I can select ICS. And now I can see a whole bunch of ICS systems from their screenshots that have VNC that are wide open to the entire internet with no security whatsoever enabled on them at all. So these are almost 200. What do we got? 198 of these things. All right. So what Shodan is doing is it's inventorying what are the ports and services that are exposed to the wider internet. It is also doing screenshots for the different services that are screenshotable. So that's what Shodan does. And Shodan says these are the ports that it sees, right? It's looking at Telnet, SIP, real-time streaming protocol for like webcams and things like that as well. There we go. All right, so we're going to take a quick break. We're going to take 10 minutes, and we're going to get into TCPdump and Wireshark. And then we're going to just start kicking out the jams and start doing some labs here, folks. Is Shodan legal? Yes, mostly. Stick with me. Ask that question on the other side of the break. 10 minutes, folks. So, all right. So we left off on TCPdump, okay? So TCPdump is a tool that allows you to sniff network traffic, okay? And whenever we're downloading this, when we're downloading and running this, we want to know what interfaces are available to sniff on. So you have a number of interfaces on your computer. I don't have any wireless adapters with me, but you have like wireless adapter, right? You have the Ethernet adapter, which is the fat phone plug. You have various loopback adapters so your system can communicate with it as well. So if we go back to my instance right here, let me kill this really quick. I can do TCPdump minus D, and it'll say these are the interfaces that are available to me, right? So I have ETH0, I have any captures from all interfaces, local loopback, I have the Linux netfilter log interface, and the netfilter queue interface. So this allows me to identify what is the interface of interest for me to sniff on. Now, this is a little bit easier with Wireshark, and I want to get into the point where people know that whenever you're looking at Wireshark or you're looking at TCPdump, they are in fact completely different tools, and they have different purposes in life. They are both sniffers, right? Like ostensibly, they're both sniffers. That's what they do, is sniff things. But at the end of the day, the way that they go about sniffing is different between each other. All right. So we're starting out with listing out on the interfaces for TCPdump. Next one, we can actually look at the X and the A. This allows us to read in, or allows us to start dumping like the hexadecimal output and the ASCII output associated with those packets. So let's go back to this VM, right? So I'm going to go ahead and I'm going to fire up TCPdump again, but I'm going to put in the -X. This will allow me to look at the hexadecimal output. So now if I make a connection again on this system, right? If I make a connection again, my terminal is not responding. There we go. And I split this one, and I'm going to open up two netcat instances again. Okay. Little bit behind. There we go. Split the tabs. All right. So I go netcat listen on port 2222. And then I make a connection, right? So I go netcat 127.0.0.1 on port 2222. And I make that connection. Now I'm able to see the hexadecimal values associated with the packets that are being sent. So where you see this 4.5 at the beginning, that's IP version is 4, and this is the IP header. And then we get into the TCP header, which has the ports on it as well. Now, with this, we can actually do this a little bit different now, and I can actually try to focus on the ASCII decode of these packets. Let me kill this, and now let's put in the ASCII so I can see what is actually being sent. So if I have one side of my netcat channel and I send a string of A's through, like this, goes through on the other side, now my sniffer is showing those A's right there. Okay. So I can see what's in the content. But wait, there's more. I can take that A and I can couple it with the X. Now I can see both of them. Now I can send through a string of B's. Send that through. Now, if I look at it, now you can see these B's and you can see the hexadecimal value of those B's is 4242424242. Capital A is 41414141, and so on. So now we can see what is being sent back and forth with TCPdump, and we can see inside of those packets. All right, I can read in a previous capture. So I can use W that allows me to write out that packet capture so I can save it. And this is one of those areas where TCPdump shines. Okay. This is one of those areas that is absolutely phenomenal. It is very high speed compared to something like Wireshark. So we can run very high speed captures, drop them down to files, and then we can read those files out with TCPdump with the -R, and then all the other options still apply as well. So there's our write. It allows us to write the file. All right, that brings us to our first lab of the day. Let me show you how I do my labs because I do it a little bit different with the VM. Let me show you how. So what I like to do is this. All right. So I like to have my VM here. Okay. And that's where I do my work. I like to have my labs be in a separate tab. Okay. So I can move through and I can go through this and just make it go really, really fast. Just so you know, Cloud Lab, super duper duper slow. But it does work and it works well for me as well. So, all right. So we have this. So we're doing intro to SOC core skills. And the first lab that we're going to do is the TCP dump lab. So inside of this lab, it has commands that I run as well. So I am going to open up my prompt, which I already have open, and I'm going to cd into mount C users. I'm going to right click and copy that command. And then I paste it in by using type clipboard text. If I do that, it pastes it directly into my terminal. Then I can read in a packet capture. Now, the goal of this lab at this point, just so you know, isn't like we're going to go hunting for malware. We're giving you the main commands that you would use to kind of filter this traffic back. So we're going to go ahead and we're going to type in that clipboard text, and it's going to dump that magnitude PCAP file from us. And we're just going to copy and paste it in. There we go. And now I hit enter. There we go. And there's all of my packets. All right. So let me share a link to the GitHub repository up there. Can share it again. And it is also available on the desktop as well. You can click to it. I don't use it within the desktop whenever I'm using the Cloud Lab VM. I like to have a separate tab open for it. So this lab is going to take us about to get started, it's going to take us about 10, 15 minutes to get people in the VMs. And then we'll get started. So let's put 15 minutes on the clock for the lab, and then I will do the walkthrough. So get rolling, everybody. If you need any assistance, please hit up tech support. All right. So let's go through this lab, and then it's literally going to set us up into the next lab, like just one straight into the other with it. So I've got too much monitor real estate. Where's my mouse? There it is. And I'm going to shut off my dingy dings. Ding ding. Tell my phone I'm now sleeping. Do not disturb. All right. So the next one, we're actually going to put in some filters where we can actually put in a host filter and a port filter. And that is cool. I mean, it is exactly what it says on the can, right? So if we do type in the clipboard text, it's telling them we're going to read in that PCAP. We're going to say we want to be looking for just this host. Now, how this would happen in terms of an actual incident is you would have a host of interest. It would be something like a user says, hey, I believe my computer system is compromised. I need to research it. I need to look into it. And that's fine, right? This is like the starting point. And port 80 says, I want to see all the traffic coming and going to port 80. Now, I can also take this and I can put in some additional filters on the back end. I can do that AX filter. Now I can see all the hexadecimal data and the ASCII data as well. And right off the bat on the right-hand side, you can see some pretty heavily encoded data showing up again and again and again over here. So we have the offset, we have the hex, and then we have the ASCII decode showing up as well. So notice the difference. And like those packets are that's showing a lot more data at this point. Whenever I remove those filters, it's just going to show me the straight packet header information, right? Same packets, but kind of a different slice and a different view on it as well. And yes, you can actually grep out timestamps. Now, when you start getting into weird grepping things, I would strongly encourage you to look at T-Shark. I might actually replace this section at some point with T-Shark in the future. So we already did the ASCII decode where we can see it. And you can see that hexadecimal data, it is base 64 encoded. Now, how do we know that? So if I zoom in on this, we can do some quick research, right? So let's pretend you're a SOC analyst and you see this, it says new object IO memory stream. What the hell is that, right? So let me go through and run this really, really quick. And I'm going to pipe it through less. So let's take this, copy that, make that there, put that in. And now I'm going to pipe it through less like so. And I'm going to look for these types of, we're going to look for anything that has that right here, new object IO memory stream. Now, what is that, folks? What is that? Whenever I say new object IO memory stream, what is that? Anyone know? Yeah, it's PowerShell. Now, there's some people that are like, how the hell am I supposed to know that? I'm literally here at a beginning class in computer security, and you expect me just to know that that's PowerShell? How am I supposed to know that that's PowerShell? This is one of those things where I'm just getting started, and this is all stuff I'm supposed to be born into the universe knowing the new object IO memory stream is PowerShell? How am I supposed to figure that out? God damn it! All right. So aside from panicking and doing all of that, how would we know that that was PowerShell, ladies and gentlemen, boys and girls of all ages? Google. Yeah. Like I hate real talk. Okay. The vast majority of the people that you think are absolutely brilliant in IT, they just Google shit. Yeah, that's it. I'm sorry, but that's that. You could even use AI. Use Chat GPT. All right. So here are my 3 rules for troubleshooting anything in IT. All right. Ping, port, parse. All right. Ping, port, parse. So ping means you're going to send an ICMP echo request. You're just going to ping a system to see if it's alive. Port is the port that I'm trying to communicate open. And then parse means parse any output that you get. Error messages, header information, things that say new object IO memory stream. You're going to parse that data and you can run it through Google. So like literally what I would do is I would just take this, right? New object IO memory stream, right? And I would take that and then I would open up a browser and I would do a search for that, paste that in. Now I'm going to do that search and it says PowerShell, Huntress Labs, deep dive, PowerShell payload, one Google search away. Now I used Bing. Please don't judge me. But Google would work too. So I used Bing, much to my surprise, and now you're judging me. All right. So that's easy. Now we know that this is PowerShell and it says convert, which means it's going to convert. And it says from base64 string. So I know that this data that I have right here, this is all base64 encoded data. All right. So we have some base64 stuff. All righty. So let's keep going with that. So that's how we found that out. I did the A and the X. Oh, we can also do filtering on protocols, right? So I can do TCPdump, don't resolve any names. We're going to read in the magnitude 1 hour PCAP. So we're going to Control L. Here we go. Type in the clipboard text. Now it's going to show us all the IPv6 packets because TCPdump can do IPv6, which is pretty neat. And then we can also do search within a traffic patterns that are out there. Also, Daniel has an amazing website and this amazing cheat sheet on doing just all these different things with TCP dump. So please, please, please check out Daniel's website. He's absolutely awesome. I love Daniel and everything that he's doing out there as well, which I think is really cool. All right. So let's go ahead and let's jump back into some slides because we're going to talk a little bit about Wireshark and then we're going to get into a break and a lab dealing with Wireshark. So Wireshark has the same type of thing, but the way it actually displays out your interfaces is kind of cool. So if I do this, let me go ahead and close this all out. Close all, and I click on Wireshark. Wireshark is going to actually display to me which of the interfaces are active. So here it's capturing the local interfaces, and I'm not going to install any updates. Please don't, because it changes things. But you can see these are the adapter interfaces, the local area internet connection interfaces. And if I were to open up a browser and go to a website, you're going to see that this WSL interface just did a spike. So that is the interface that actually has traffic going on it. So it gives me some type of visual cue and representation that that is an active interface with traffic. There we go. If I want to, I could also do a ping. So let me go ahead and just open up this interface. And then I'm going to open up a new prompt and I'm going to ping 127.0.0.1. There we go. And I completely messed that up because I'm using the wrong one. Let me do a ping of 8.8.8. Let's do this. Give it a -T so it just keeps going. Continuous. There we go. And let's go back to our interfaces and let's see which one is sending those packets. Let's open up Wireshark again. Right. There's our Ethernet adapter right there. So I'm going to open up that one. And you can see our ICMP echo requests. All right. So there's our ping packets. We're also seeing some TCP and UDP. It's just Windows standard background traffic, but you can see our ping traffic going back and forth, which is pretty cool. Next up, if we look at the packet, now this gets really into the OSI model and why the OSI model is complete and utter garbage. And we should never teach the OSI model ever again. Like, just stop. Just don't do it. Please don't do it. And let's talk about why you shouldn't do it. This is something that was basically forced upon the IT community years ago, and it was dumb how it happened. So with the Open Systems Interconnect, whenever they were coming up with this model, they got into an argument. So let me give you an example. Can you tell me what is the presentation layer? Like, what is, if you're looking at OSI, what is the presentation layer? Oh, Justin, I will win. Really? The presentation layer is the browser? It's the app? Okay. All right. It's the GUI. It's the application. Awesome. Cool. All right. So I'm in Wireshark right here. Let me stop this capture. Let me go up to any of these TCP packets. Let me go up here. I got some green. All right. Where in Wireshark do I see the presentation layer? Folks, where do I see it? It's not layer 3. Layer 3 is layer 3. No idea, nowhere, you don't. Oh, it's, but it still should be there. Even if it's encrypted, it should be there. But let's say it's not encrypted. I don't go to an SSL TLS website. Where is it? Like, show me on Wireshark. I want to see all of the presentation layer traffic. Where would I see that? Where would that be? I like that it's inside layer 4 because it is layer 4. All right. So instead of the OSI model, it's in your heart. Instead of OSI, you really, really should be teaching and pushing the Stevens 4-layer model. All right. So the Stevens 4-layer model makes sense because this is how packets work. Your router doesn't do shit on the presentation layer. Your switch doesn't do anything on the presentation layer. In fact, your firewall doesn't even do anything on the presentation layer. Also, how did the presentation layer come about? Excellent question. This gets into weird things about just blindly accepting authority when authority is dumb. The reason why we have a presentation layer is because when they were coming up with the OSI model, there was a company in Germany that called their application layer the presentation layer. And there was a huge argument, geek fight, where they were fighting over presentation layer, application layer, presentation layer, application layer, presentation. And finally, OSI said, screw it, we're just going to create 2 separate layers. It's the same thing. It's the application layer. So when you're looking at these things, when you're looking at it, this is what makes sense. And this is a breakdown of how it ties. Oh my God, there's a lot more here of how this actually ties together right here. And notice how the OSI model, the application layer and the presentation layer are just the application layer in the Stevens 4-layer model. And the reason why that's the case is because I can go into the payload for the application here. So I can actually look at that payload, the TCP payload as well, and I can see it, all right? Once again, there is no presentation layer in Wireshark, right? Session and transport adjust the transport layer because that's the way it's actually shows up as a real packet in the transmission control protocol. Both of those are together because it's in one packet header grouping, right? So when you're looking at this, we need to stop teaching the OSI model. We need to start teaching the Stevens 4-layer model instead, because it makes sense. It's how packets work. We have switches that do media access control physical layers. We have network devices and router that route based on internet IP address. We have TCP header information that's transport, and then all of the applications that are in TCP are just in application data. And that's what's actually shown inside of Firefox, not Firefox, Wireshark. Yes, it is absolutely a lot more concise. It makes sense, and it maps over to what you're going to see in TCP IP. It maps over to what you're going to see in Wireshark, and it makes your job much, much easier. All right, so there we go. So close that rant out for just a little bit. You also have the ability to follow a TCP stream. So I can click on any one of these packets, right click on it, and I can do follow TCP stream, and it shows me all of the data that's being sent, as in the application data that's in that TCP stream. Go. And yes, there is encryption here. There we go. Next one, we can get statistics. We're going to do a lot with statistics in the lab that's coming up, but we can do statistics. Let me close this out. Love this. So you can go statistics, you can go conversations, and it's going to say, what are all the different systems my computer system is communicating with? And I can sort this by the number of packets, or I can sort it by the amount of data that's being sent and received. And this is super, super powerful because when you're trying to find malware, you're going to start on 2 sides of the curve. You're going to start on the fat head and the long tail analysis. So I'd be like, what is the top talker my computer system is looking at right now? And I can do apply as a filter right here, and I can see all of that traffic going between these 2 systems. And now it's automatically created the filter for me where it says the IP address is equal to 10.10.1.2, and the IP address is equal to the remote IP address. So I can go from statistics where it's like, this might look interesting, to the point where I can quickly drop in and see what that data actually is. Same thing with conversations. You're going to do this in a little bit. Protocol hierarchy. So I can go statistics, protocol hierarchy, and it'll give me what is the breakdown of protocols. You can see it's IPv4 transmission protocol, hypertext transfer protocol. The vast majority of my packets are HTTP packets. Okay. That's also because of the filter. If I do this, hold on a second, let me see if this clears this a little bit better. There we go. Now we go statistics, protocol hierarchy. Notice the protocol hierarchy just changed. Where when it's displaying the statistics in the protocol hierarchy, it's doing it based on the data that is currently being displayed. right? Somebody said easiest way to do this on a regular basis. You can actually do this with Wireshark on your normal computer, probably just having Wireshark running in the background, pretty easy. If you're running, usually where you start getting into trouble is when you're trying to do Wireshark for packet capture off of like way more than just a system. Wireshark can capture traffic from a single system, no problem. But when you're going off of like a gigabit switch, that's where Wireshark is going to start to struggle with that level of data traffic. So hopefully that answers your question. What are the actual HTTP requests? So if I go statistics, HTTP requests, it'll show me what are the requests that are being made. Now, this is really important because whenever you go to a website, like right here, it says MS Edge BTLU DL delivery Microsoft.com. That was my request that was made. It's not going to show me every single individual, like, HTTP session, but it's saying this is the request that was made. So it allows you to get down and find some potential malware a lot faster, which is what you're going to see here in just a little bit. All right, so now we got a lab where we're going to use Wireshark. So in this lab, we're going to just open up Wireshark right here. And then we're going to open up the magnitude 1 hour PCAP file. This is a previously captured session. And we're going to work through this lab. And what we're going to do is we're going to use the different things that we just talked about, where we are able to start using these techniques that I would look at any packet capture to identify malware specimens on this as well. Will all the training and resources be available later? Yes, absolutely. It will be available after class. We're making this as available for people as we possibly can. So we've got Wireshark. We're going to be sharing that out, not sharing it in, there we go. There we go. And you're going to look at this malware specimen using the techniques that we just went through. Okay. And then we're going to add some additional things on at the end as well. So this lab takes us a little bit longer. We're probably going to have 15 minutes for this lab and then 10 minutes for the break. So we're going to resume at 25 minutes from now because I want to make sure that people can hit the restroom, they can get some lunch, and they can do all of that. So with that, let's kick out Bo and let's kick out the jams. We will resume in 25 minutes. So the Daft Hack, or the No Bandwidth album that is coming out is associated with this. The future is, and I think I have a link. Where you can take a look at it. And I think we have an online version of it. Maybe I don't. Someone can find that for me. I think it's with Raka. I had it just the other day. If someone can find that for me, that would be awesome. But it's the online version of this. But what the No Bandwidth album does is it is the soundtrack for this. Okay. So right now, this is the future is Ashcan version. And it's very small, but this is going to be an entire graphic novel. I've got, just give me a second here. I know I have this. Hey, Zach, do you know where the Ashcan for Reka is? Like the actual, there we go. Got it. Awesome. Here we go. So let me pull this up, put this down here. There we go. So you can actually see it because I want to talk about what this is. So Bo, through No Bandwidth, is creating a soundtrack for this. So whenever you're talking about different sections of this comic, which I'm going to pull up here in a second, kind of walk through what this comic is, the soundtrack will shift. So there's theme songs for each of the characters and everything. So he's creating all of that. Let me zoom out here again. So the idea of the future is this is some point in the future, right? The big thing about the future is, and what we're doing is, it's a augmented reality future. So if I'm looking at what's going on and kind of the reason why I kind of created this world with Jason Blanchard, and I kind of came up with a framework for what the comic would be. And then we have writers come in and then write in the universe that we created associated with it. Is what does the future look like whenever we have augmented reality? Like, if we're looking at it, I can't see us all just staring at phones into the future. I think it's just a short period of time before we start jacking things right into our skull or using glasses and things of that nature. Now, if you notice on this comic, it's black and white down here. The reason why it's black and white down below is because when the real comic comes out, that will be completely colored in, and there'll be barcodes on these vials of blood that they're standing on, and that will kick off mini capture the flags. In fact, inside of the Futurist comic, if you go to the first page, there is a mini CTF challenge right here. It also has a page where you can get the official soundtrack from No Bandwidth and Bull Bullock. Once again, I'll put that right here. And then it gets into the comic proper. Now, if you ever have seen like a James Bond movie, you know how James Bond movies always begin with the monster action set piece and then it goes into the story. That's what we're doing with the future is. And that's what this first ash can is. This is actually the big set piece that's closing out a previous story, and then we're starting a new story. So it's very similar to it. So right here talks about the characters in this hacking group. We have Martina, who's wet work. This is Wheeler, is kind of the main, the kind of leader of the group. If you notice, he doesn't have implants for his augmented reality. He insists on using real glasses. Arf is a dog. His name is Arf. He's really important later, but he's ARF. And then Eli is the person that hacks and finds vulnerabilities. And then Sally is the hardware person. And each of them have their own backstories and things of that nature. So in this initial like Ashcan, the entire team is hacking into servers that are stored in the ocean. The reason why they're storing these servers in the Arctic is because in the future, cooling is really expensive, and there's already been a lot of work that's been done to basically put servers underwater so you can get all of that cooling directly in the ocean itself. So we have a topside crew, and then we have Martina is underneath. You can read all of it. We have a bunch of pirates that they're working with that are trying to sabotage and double cross them. Wheeler actually takes the guns. All of these guns they have are cheap firearms that are basically sold to dictators. So people can't turn the guns against the dictator. And you can see the gun backfired there at the person. Now, this next one is stupid, but I'm going to tell you right now, they thought I wouldn't allow it in the comic book. So the main writer is Fred. And Fred is the author of Cowboys and Aliens. And he does some really cool stuff, and we go back and forth, and we kind of go with ideas and things of that nature on that as well. And with this, he put in some dolphins that have freaking laser beams on them. So these are militarized amphibious animals, and they've been bought off by Wheeler by giving the codes to a salmon farm, just because, you know, why not? So we have the dolphins and things like that. Now this particular person right here, does that guy look familiar to you? Lower right hand. Like, who is that? Who is that? What does that look like? That's John Hammond. John was one of the main Kickstarter supporters, so he is a character in the comic, and we're going to hand deliver the full graphic novel to him when we get it done. We're actually going to fly out there as well. So, yep, we got the orcas. They're in it as well. And then, of course, you know, kind of setting off the next story and what's going on. So this is the comic. The music that you're listening to is from this as well. So just giving you a little bit of background on what we are doing, because there's a lot of stuff that we do at Black Hills Information Security and anti-siphon security training that truly, you know, a lot of other training organizations don't do, because they actually like making money apparently that's the thing to do, I guess, which is pretty cool. So I need to restart my application. Let me come back. There we go. Jump back in, connect in, and then we'll do it. But we just did the Wireshark lab and kind of want to walk through that quickly so everyone can get familiar with it. By the way, if you all could do me a big favor, could you please go on Twitter and do a shout out to the Cyber Mentor, by the way? I don't know if you guys know the Cyber Mentor. He does all kinds of really cool, affordable training. Heath is awesome. He's keynoted our conference. If you could all go out there, yeah, you could do LinkedIn too. I think that that's fine. Heath has kicked off some pay what you can training as well. And that just makes my my heart so happy. So if you could go out and say thank you, say that you're in this class and just kind of point out to him that thank you for what he is doing in the community, I would greatly appreciate it, because we're trying to get as many people in the industry to start moving this way instead of looking at training as like this cash cow, where you can get yachts and jets and things like that, but truly trying to build it around how do we help people as much as we possibly can is really what we want to focus on. People that put people over profits are the best kind of people, and they're starting to do some pay what you can training, which I think is pretty awesome. So kick on out and say hi. I would really appreciate it if you all would do that. All right, so let's jump right into this lab. So here we go. So I'm going to open up the PCAP file like this. Just open it up. There we go. Now it's open. Oops. Now, what do my instructions tell me to do with this PCAP file? So now that we have it open, we can see all the different packets. We break down what are the different windows. We've already talked about how Wireshark breaks down the packets from an overall, this is the source destination protocol. And if you select any of the hexadecimal data at the bottom, this middle window changes. So it tells you what these different things mean. So if you're trying to learn what different parts of packets do and how they actually work, you really can't do any better than using Wireshark, capturing packets, and just kind of like selecting through like, okay, so this is user datagram protocol. What do we have? We have the source port, the destination port. It is link local multicast name resolution. What is that? I'm sure that won't come back to bite us in the ass later. But we can see the queries that are being made. You basically can learn about what these protocols do and how they work by the breakdown of the windows inside of Wireshark as well. So now we're going to go into HTTP statistics, which I kind of already did earlier, but we can look at the requests and you can see the requests. Now in this, we have weather.microsoft.com. We have updates from Windows, but then we have this weird request for wilfordcostume.bayamoon.com. That's strange. Weird. What is that? I'm sure that's not going to be fun later. All right, well, let's keep digging into it. So we can start to see those requests and we can see one is a little bit different. So now we have the conversations, like who is talking to who. And what I'm going to do is we're going to select IPv4 and then we're going to sort on the packets. So let's go ahead and do that. Let's go statistics. Let's go conversations. We're going to look at the IPv4 and we're going to do packets A to B. There we go. And we can see that this is a lot of traffic between these two systems, between 68.183.138.1 and then communicating to 192.168.99.52. That is a lot of data going on between these two computer systems. So now I'm going to go ahead and set up a filter on that. And now it completely changes my screen so I can see all the traffic between these two computer systems. So once I'm in here, I can right click on any of these and I can do follow TCP stream. And now it's going to bring out the application data to me, right? So it's going to get rid of all that header information, all the TCP, all the IP, all the 802.2 header information. Going to make it go away and then bam. We have this right now that says this is a request. Get request came trying to get this information from Bank of Botswana as a referrer, and then it responded back with this PowerShell information. Now we know it's PowerShell information, right? We did that through a Google search a little bit earlier, so we can see that it's base 64. We know it's PowerShell. We know shenanigans are at play here. We got that. We're all caught up. So we can see that encoded data as well. We can also do a search on different protocols. Like I can do this, go up here in my filter, and I can do LLM and R, just put the protocol in like that. And then it auto completes. And then if I do the little blue, it gives me all the LLM and R traffic. And you're going to see how this is a really bad thing here in just a little while. We'll be looking at that in a little bit more detail. But now we can see all of our link local multicache name resolution traffic out there. Here we go. We can also do IPv6 because why not? And we have all of our IPv6 traffic. We can see we've got our multicast traffic. And then one of the things that I think is really, really, really super cool is you can actually do a search. So you can say HTTP contains new object. And this brings back every single packet that has our PowerShell that is somewhat suspicious. Got to stop doing that. Type in the clipboard text. There we go. And now this is every single packet that has that HTTP contains the header information that has the PowerShell in it as well. Now, the final thing that you can do if you want to play around with it is we can do, let's go follow TCP stream again. And let's say that we've got this PowerShell and we've got this base64 and we wanted to try decoding some of it. Well, you can. So we can take a base64 string and you can paste that into something like CyberChef with the packets as well and see if you can decode it. See if anything is readable in it. Now we've got some forward slashes and some pluses. Those are going to give us some heartburn, of course, but you can filter all of that out. If you actually use HTTP decode, you can actually use the ignore garbage and it'll blow out those characters and just won't do anything with it at all. So we can actually use CyberChef to decode this base64. Now, a question is, just because it's PowerShell, does it mean that it's evil? Well, no, it doesn't. It doesn't mean that it's evil. It just means that it's PowerShell, right? So we'll put this in, and we've got some base64. Looks like it has some more encoding, and it really, really, really hates those special characters because those are not base64 characters that are valid at all. They're just in there. Now, part of the reason why attackers put this stuff in is because it breaks up it actually breaks up the data in such a way that a standard base64 encoder or decoder isn't going to deal with it properly, because those bad characters, whenever you throw that at a firewall or an intrusion detection system, it will puke all over it, which is kind of what's going on there too. All righty. So there we go. All right. So that is the Wireshark lab. And really, once again, at the end of this lab, we've given you a bunch of packet captures that you can look at in the TCPdump lab. I strongly encourage you in spending some time getting familiar with those data structures that you have. So you can pull in those packet captures, you can start parsing that data and start hunting for the malware in those packet captures. Now, we haven't gotten into what are some good ways to actually do a search on identifying potentially interesting packets inside of a packet capture. That's going to come up a little bit later when we get to the active countermeasures RETA portion of the lab. We're going to have a day, or not a day, we're going to have a section where we're literally going to be like, here's how you can do beaconing and frequency analysis to be able to identify potentially interesting data streams. And then you can start carving them out a little bit more with tools like Wireshark and TCPdump as well. All right. So now we're going to be moving on to Linux. Now, I intentionally set this up. A lot of classes that you see out there, they like to start with Windows. And I think that that's an incredibly bad idea. The reason why I think it's an incredibly bad idea is because if I start with Windows and I say we're making a connection to a port, people don't know what a port is, right? And if I say something like TCP, it's like, I don't understand that. So to be able to understand backdoors and things of that nature, you first have to understand networking and how network protocols actually work. When we're going to get into creating malware, we're going to be creating malware, but we're going to be using Linux to create that malware on a Windows computer system. If I start straight in with Windows, then I'm like, well, here's protocol network traffic. And, we're using Linux to create this backdoor, and people haven't been exposed to networking and they haven't been exposed to Linux. It really kind of like is tough to wrap your hand around or your head around those things. However, if we start with networking, then we move into Linux. By the time we get to Windows, which is where you're going to spend the vast majority of your time as a SOC analyst, now you're ready to rock and roll and really get into understanding how those different protocols and how those packet captures and how that traffic works properly to be able to detect malware on a Windows computer system. So we're going to be looking at Linux, but we're going to be looking at Linux once again through the lens of how do we identify potential malware on a Linux computer system. So that's through the lens we're going to be looking at these. And the only way you can do that is by creating some malware on a Linux computer system, which I think is just fun, right? So when we're looking at Linux, the first thing that we have to identify is what is the directory structure of a Linux computer system. So if we look at bin, so let me go over here to this system. This system's not going to last much longer. You know what I'm going to do is I am going to go here. I'm going to go back to my applications and I'm just going to start up a new one because this guy has 30 minutes left. So I'll just start a new one there and then we'll jump back to the running copy. There we go. Let's change that to be full screen. There we go. That looks good. All right. So I'm going to open up a terminal command prompt. And we're going to jump straight into our Linux Ubuntu shell. There we go. I'm going to become root. We'll talk more about what that means here in just a second, but I'm going to cd into the bin directory. So bin is where binaries exist, right? These are where binaries exist. Binaries like ping, less, more, all the different commands that I run, they're in this directory. Now, one of the things you'll notice with Linux systems is they really like to break up like binaries and service binaries and configurations into separate directories where they can process and they can run. So it's easier for somebody to actually identify where something is. You have a lot of people that say, well, I like Windows better than Linux because Windows is easy and Linux is hard. If you ever say that out loud with your flappy gums and your voice doing vibrations so that other people can hear you, that only proves two things about you. That proves, number one, you don't know very much about Linux, and it proves, number two, that you know even less about Windows. Trust me, the organization of a Linux operating system is far cleaner than a Windows operating system. Usually when more people are talking about Windows being easier, it's because there's a GUI. But trust me, there's a limitation with GUIs that becomes an absolute pain in the ass, and you will be exposed to that here in just a little bit as well. So with this, I'm in the bin directory, and this is where binary files exist. So I want to show you something here real quick. If I do which ls, it says the command that I just ran, ls, resides in bin ls. So I'm in that bin directory where the binaries exist. The reason why I can run ls without having to do bin/ls is because ls is in my search path. All right. So whenever your system starts, if I do echo and I do $path right here, these are the directories that anytime I run a command from my bash prompt, it's automatically going to try to execute the commands that are in those directories, okay? So here you go. You can see that it's automatically going to search in user local sbin. It's going to search in user local bin, user sbin, user bin, sbin, bin is where we exist, and then also in the games, and then snap bin as well. So if you run a command like ls, it's going to check every single one of those directories to see if the ls command exists, and it's going to run that. And the one that it runs is the one that's in the bin directory, right? So it searches through all of those different directories. So that's the bin. If we go to boot, it's bootloader files. Oh, dev. Let's go to the dev directory. CD into dev. Now, everything on Linux and Unix is a file. This is a very, very important thing to understand about the structure of Linux and Unix is everything is file. Memory is a file, the CPU is a file, like your display is a file, your mouse is a file, your teletype terminal is a file. Everything is a file. Different types of files exist. You have some that are device files. You have some that are straight files. Some files are technically directories as well. I know that that seems weird, but when it's specifying inodes on a hard drive and where you're going to go, it looks at everything through that lens for saying it's a file. Now, there's different types of device files, and we're going to create some device files as well. But this is the dev directory. So I could do something like cat dev u random, and this is just something that just generates random bits. It's a file that does something, right? I can get kind of crazy with it. So I can do dev, let's do this. Let's do cat dev urandom, pipe it through strings, see if there's any printable strings that come out. Yeah, so it's just generating random noise. I know that that's kind of weird, but that's Linux, right? This is a file that does nothing but just generate gibberish. That's it. Trust me, there's value in that, especially when you're generating nonces and you're dealing with encryption and things like that. The etc. directory. So if I cd into etc., etc., etc. Now, one of my favorite things about Linux is almost always the configuration files for core services are in the etc. directory. So if I want to look at what is the configuration for SSH, it's going to be in the etc sshd directory. If I want to look at what's the configuration for MySQL, it's going to be in the etc MySQL directory. And I can see these config files and I can process them. Like some of the config files are system config files. Like I can let's less out password, right? This is the file that has users on my system. It does not have password files. That's kind of weird, but that's a longer conversation. If I want to see my password hashes, they're shadowed because the shadow knows. And if I go to the bottom, here's my password hash for my ADHD account. But that's considered a configuration on this system. That's in the etc directory. The home is basically where your users' home files are. So if I look at this, there is an ADHD user. And the reason why it's set up like this is because if you have multiple users, they will all have their own directories here. And that's where their documents will be. That's where their downloads will be. That's where their individual configurations will be for their shells and their terminals and any other applications like Firefox and things of that nature. That home directory is literally a home directory for that user as well. Lib. All right. So if we go to the lib directory, this isn't some type of derogatory political term, like I'm going to own the lib directory. So if I'm in the lib directory, this is where libraries exist, right? And with your operating system, I want you to think about your operating system and how it runs literally like a library. Okay. So when your computer starts, it has something, all of our computer architectures are microkernel architectures. We don't really have any computers that are monolithic kernels. A monolithic kernel would be the operating system is completely welded shut. It does everything. You can't add anything to it. With our microkernel architectures, they start with a very small kernel, and then you start adding functionality onto the kernel as the system starts up and as different applications are needed. Now, when you're running that, your operating system will do something like the dynamic linker, and it'll use procedure linkage table, global offset tables. It'll use these tables to where it'll invoke things like the dynamic linker that'll go look up a library and pull up functionality out of that library, almost like a real book library. So if I want to invoke copy and paste functionality, imagine a great big library and there's a book of, let's just say, standard IO functionality that has copy and paste. And my operating system's kernel can go to that book, which is a file or an SO, shared object library, and it will go to an offset within that file, pull that code for copy and paste, and execute it, and it will load it into the microkernel architecture. So your operating system is constantly going into this library, and it's constantly loading these object library files and unloading them. So that's what your computer is doing constantly and learning how these things work. If I run LSOF by itself, you'll see that there's a ton of these different files that are being invoked on the operating system. So that means list open files, and we'll spend some more time with that here in just a little bit. So that is the lib directory. What else do we have? Media, that's for like CD-ROM, USB sticks. Mount is the way you should be mounting things. If you mount a drive or you mount a remote system, you can use it and mount it directly to the mount directory for temporary file systems. Opt. Okay, so opt is kind of weird. The reason why opt is kind of weird is it allows you, well, it doesn't allow you, it's just how people use it. Sometimes developers want the entirety of the application bundled in its own directory. So if I were to go into John the Ripper here and type ls, I have doc run source. If I go into run and I type ls, we have a bunch of files in here. But notice it has its own lib directory, right? That's because John the Ripper has its own libraries in its own opt directory. So instead of loading everything into the lib directory and bin directory and all those, it's containing everything that John the Ripper needs into one directory. And that's, in this situation, that's the opt directory. And to be honest with you, you can put whatever the hell you want in the opt directory. There's no rules associated with it. But for a bunch of the tools that I installed on this VM, they wanted to be bundled in their very own self-contained directory. John the Ripper, Responder, Veil, Conpot, Convert, Cowrie, Honey Badger. They just wanted to be everything loaded into their own directory. And that's what I did with opt. Also sbin, mentioned binaries, right? So if I go into the sbin directory, these are files that are binaries, but they're like system binaries. So you can see that we have tools like fdisk, fscheck, what's meant, ntfssp, log save, log setup. These are all binaries, just like the standard bin directory, but these are binaries that are specific to the maintenance and the management of the system, right? System or service binaries, right? So these are the ones that we would use to maintain and manage the computer system. So that's sbin. What else do we have? Serve, just data for services. I see opt used much more regularly than services. Temp is for temporary files, like log files. A temporary file would be a file that is going to change rapidly or disappear. So you'll see temp files. Sometimes it'll be logs for like a browser. Some download stuff like partial download files will be in there. Also var would be for var like logs as well. User. All right. So if I go into the user directory, like so, here we go. These are user binaries. So we have user libraries, we have user bin, we have user sbin. So we have user binaries, which are just straight binaries that we can run. We also have service binaries. Now that's weird because we had sbin. What is the difference between sbin and just straight user sbin? So I want you to think of like a game, like a multiplayer game, like Settlers of Catan or Unreal or any of those different games. You can start up and run a server and a service as a user on a high non-privileged port, and you would be using a service binary to do that. It doesn't require low-level access to the operating system or anything. It's just a service that's going to run on a high unprivileged port. So that'd be for like user services as well. var, like I mentioned, for log files. Root is root's home. Like if I see any in root, not tor. Boy, talk about Freudian slip there. This is the home directory for the root user, and I am currently root on this computer system, so I can access that directory. And then proc. I love proc. We have a lab coming up that is one of my favorite things, and in it we talk about the proc directory. It doesn't exist on the hard drive. It exists as a virtual file system or virtual directory at runtime. Every single process ID on your system has its own process ID number. And that process ID number is its own directory where we can see what the current directory is. We can look at what the executable is as it's loaded into memory. We're going to do some field expedient forensics with that here in just a little bit as well. All right. So users and privileges, anytime you have a $ in bash, you are not root. I've already talked about this a little bit, but whenever I become root, sudo su, so that's just basically switch users and do something. In this situation, it's saying switch users, do something, become root. In that situation, it's going to ask for my current user's password to allow me to become root. And then once I'm root, I'm root. Hidden files. Weird thing about Linux systems is there's hidden files, and it doesn't mean they're maliciously hidden files. There are certain things like configuration files, like here you got a config file for my profile, my bash RC, for Docker, for cache. Those are configuration files. I don't want to see them all the time. So what you can do is put a dot in front of those files, and then it won't display them unless the A flag is provided. So you can do ls-lrt. A means show me the hidden files as well. Make dir, just like Windows, making a directory, make dir test. If you want to find a file, Linux automatically indexes the file system. So I can do locate and do a file name like Sasquatch, and it'll go through and find any file with the name Sasquatch. If you want to edit files, you'll be editing some files later in your class, but this is just the quickest, dirtiest VI cheat sheet. Like literally, this is your VI survival guide. These are the only commands you really need to know in VI. VI is scary, visual editor. So yeah, you can use Nano, but there's sometimes where VI is better, honestly. Unless you get Nano set up to where it can support C files for like C code. And that even gets weird, but no, VI, I recommend everyone learn VI because VI is there. Nano is cool. Kate is cool. All these different editors are cool, but Vim is there and it's waiting for you, right? So with this, if you want to edit a file, once you VI a file, you type A. If you want to be done editing the file, you hit the escape key. That takes you out of that edit mode. And then you can do colon, which tells VI, this is a command to you, VI. I'm not editing anymore. I want to talk to you. So that colon, now we're talking to VI and we say write quit and the exclamation point says I don't care about any errors. If you know how to do these things, you're going to be fine 90% of the time. Now with really large files, you'll be doing searches and things like that. But for just getting you started, this is great on there as well. Oh, Dakota State taught Nano. I'm in a feud with part of my state. I'll win. But I don't ignore Nano. I recommend VI because it's always there. Nano is a really great editor as well. With Nano, one of the best things about Nano is down at the bottom, it has some help built into it at the bottom. So the little caret is control. So control G is help, control X is exit, control O is write out, control R is read a file. So it has that set up out there as well. The difference between VI and Vim on the vast majority of Linux systems, no, there is no difference. VI is just soft linked over to Vim. Vim is the kind of next generation of VI. We used to have to do navigation with home row. If you're working with Vim, the arrows work, colors are in there. So most of the time when you're working with VI, you're not actually working with true VI. You're working with Vim, which is like an enhanced version of VI. So Vim is fine. And a lot of the stuff works between the two of them. If we want to look at the processes, we can look at all the processes on the computer system with PS, that means processes. AUX, we can say all processes sorted by a user, including the ones associated with a teletype terminal as well. All right. Processes with top. Top is cool because it gives us kind of a real-time running of the operating system. It's giving us updated usage information. Now, when I first got started working with Linux, I was hired on as help desk. This was 2000, which is like 25 years ago now. But I was hired on at a help desk and at Accenture, and I was doing some stuff with PeopleSoft and doing some C coding. But one of the things they would have me do is come in the middle of the night and watch a process. And if that process died, I would watch this. And if the process died, I would restart that process as well. That sucked. I learned very, very quickly. There was a book on bash scripting, and I literally created a tool that watched that process. And then if it died, it would restart that process automatically. And I crawled underneath my desk and I went to sleep after I wrote that program. And I woke up the next morning and there were a bunch of employees in the office. I apparently slept through a bunch of them coming in. And I remember waking up surrounded by other employees in the cube farm. And I kind of like casually came crawling out from underneath my desk and coming up and sitting down. Like, did anybody notice that? Which they totally did. They totally did notice that. And I totally got in trouble. Thankfully, I had one of the managers was cool enough that he was like, so let me get this straight. You wrote a program to basically do your work for you at night. And I'm like, I'm fired. I am so fired. I am so fired. I'm like, yeah, that's what I did. And I didn't get fired for it. He was like, that's really cool. And that's what people should be doing. And I was like, hooray. That's great. They didn't fire me that time. All right. So IP information about your IP address as well. So I can get my IP address. This is the new way that all the cool kids with great facial hair and cool hats do. I'm old. I use ifconfig. So ifconfig gives me the same information, but I think it looks a lot cleaner to me. I don't know who sits around and is like, you know what we're going to do today? We're going to spend lots of time rewriting this command that everyone knows and loves and is used into making it look like that. Like that was somebody's like month of work. The hell, man. Good night. Just crazy. All right. Ping we already played with a little bit. Ping is just an ICMP echo request. It stands for Packet Internet Groper. That's a great name, isn't it? That's pretty wonderful. But basically it's a way of identifying if a remote system is alive. We can run Nmap to find out what remote ports are on there. Oh, NetTools was bloated. That's okay. Okay. How big is your hard drive? Have you looked at your libraries for your operating system, like 64-bit libraries, and NetTools was bloated? Come on, be real. Like if you look at embedded device SCADA systems, they're still running NetTools. So there you go. So we get into these fights, like I said, nerd fights happening all the time. Ping port parse I already talked about. Nothing beats Microsoft. What is Microsoft as an operating system? Quick, what is a visual analogy? Like when you think of Microsoft as an operating system, I think of it as just a crazy bag of drivers. So, Nmap versus RustScan, use Nmap. RustScan is fast, but really most of the speed performance issues, Nmap is written in C, and trust me, Gordon is really a good developer. And Rust is cool too, right? Fewer vulnerabilities. But honestly, with RustScan versus Nmap, Nmap has been the port scanner, and the features are off the charts associated with it as well. So props to them for writing another port scan. That's cool. So, oh my God, are you trying to trigger me? But the US government says C is bad. Okay, there's literally people that came out and said we need to remove all applications that are written in C instead of Rust. Like that was a thing that happened in corporate America. And it's like, well, there goes Windows, there goes Linux, there goes Solaris, there goes OS2 Warp, there goes everything at that point. Take the bait. I did. We can look at network connections with the netstat command. Personally, I like LSOF. This is the one that we're going to use as a lab. I'm going through this kind of fast because we're going to get our hands dirty, and we're going to do this for realsies out there as well. Question is, how to get a job for someone who's new to the industry with no SOC experience? Any path you can share? Yes. Step 1, this class. Step 2, Jason Blanchard's job hunting. And step 3, how would you all feel if there was a free certification for entry-level security people, or a pay-what-you-can certification? Yes. It's coming. Sit tight. Maybe I'll have it up and running this week. We'll see. No, tomorrow. It is coming. You don't have to take, I don't want your sorry. I don't want your money. I don't know. That's fine. It's coming. I'll show you what it looks like. I've got the spreadsheet out there. We've been working on the multiple guest questions, so it's coming. Here we go. All right, so proc and processes. This is proc. I already talked about this, but we can see the process IDs and we can see them. We already did all of that. And then we have the lab. Sorry, labs coming up. Bash history, equally cool. Who wants to do a lab? Like I said, I went through this fast because I want you to do it. I don't want to walk through everything. It's funner when people get to do stuff, I think. So we're going to do the Linux command line lab right here. So is my cloud VM still, it's still running. Yay, that's awesome. So we're going to do this lab. It's going to take us about half an hour, and then I'm going to do a walkthrough, and then we're going to do ask me anything on it afterwards. So you're going to open up an Ubuntu command prompt, going to become root, and we're going to create some malware, boys and girls. Who thought that they would create malware today? Like when you woke up this morning where you're like, yeah, it's a good day for malware. Every day of this class, we're going to be playing with malware because malware's fun. All right, so jumping in, you're going to create some malware. We're going to create malware using a backpipe. What is a backpipe? Don't worry about it. I'll talk about it when we get back from the break. But you're going to run this command, and we're going to create that malware. And it's literally just a netcat listener backdoor. Then you're going to connect to it from a different window. And then you're going to run some commands. Now, at the end of that, you're going to go hunting your backdoor. So you're going to run LSOF, and you're going to see that you have an open connection on port 2222. You're going to drill into that process ID. Your process ID will be different, everybody. It will be different. Going to look at the process. We're going to CD into proc your process ID. We're going to LS out the files. We're going to run strings against that malware. We're going to find out what that malware is. All right, with that, everybody, here we go. Let's set the clock to 25 minutes, 25-minute lab on this one, folks. And when we come back, I'm going to do a walkthrough in about 15 minutes. Then we're going to get into what we close out every single day as an ask me anything kind of deal. So just so you can ask me anything, so get those questions typed up so they're ready to go. Let's get rolling, everybody. All righty, and we are back. And my coffee is cold and it's caffeinated. All right, so let's go ahead and let's go through this. I'm trying to start a fight on Twitter. Trying to be deaf. Oh my God. We're having a lot of fun on this. All right, so let's go ahead and let's get rolling from the Linux command line. And as I love to say, let's create some malware, even though I think finally this VM is dead. Awesome. All right. Let me jump back, jump into this application and get logged in. So as I mentioned, I kind of hate things that are like, hey, here's how to do this command and this command. It just becomes like this dry man pages of command. And that's just no fun. We don't want to have things that aren't fun. We go to full screen on that while that guy's starting up. So do you want to know how many people we have in right now that are running VMs? So how many running copies do I have? No. Yes. Here we are. All right, here we go. I want to share this with you all so you can see it. But this is how many of you are running instances of this VM in this class right now at this moment. So remember when I told you we have a benefactor and somebody is paying for all this? Because this isn't cheap, folks. This isn't cheap to set this up. And so I'll tell you the story here and then we'll get into the lab. How about this? Let's do the lab and then I will tell you the story about how I met Arnie and basically what he's doing for the community, which I think is just great. So let me start up my VM and we're going to open up a Linux command prompt. It's going to take a couple seconds for it to fire up. But no, while that's starting up, I'll tell you a little bit of the story. I ran into Arnie at a conference in Florida. We were just, somebody was like, you two have got to have lunch with each other and you guys have got to chat. So I spend some time sitting down at this table and I'm talking with this dude, Arnie. And honestly, I don't know Arnie from anybody. I don't know his background. I don't know anything about him. But we start talking about he does Ironman triathlons. He's actually one of the fastest triathlon athletes in the world in his age group. He's swam the English Channel twice, even though he says he only did it successfully once. He kind of did it twice successfully. Like first time he was within like visual distance of the beach. So it was really, really super close. And we got into mountain bikes and all kinds of crazy fun stuff we were talking about. And he asked me point blank, he was like, if you had, we started talking about the pay what you can training model and what we're doing and how we're doing it, what our goals and objectives are. And he asked me, he said, what, hey, if I zoom, do you guys see it zoom in or not? Yes, no, maybe so on the Zoom.
Yeah,
Okay, you
I'm
do
not
see it
seeing
when
it.
so you do see it when I zoom, Brian?
Okay, I can see your window now, but it's still very small for me.
Did it zoom just now?
No.
No, it did not. Hold on. Let me trying to figure out how my Zoom works through an RDP session through TeamViewer. Oh, we'll just use this one.
There
How's
you
that?
go.
Is that better?
That's good.
There we go.
Two things in
And
that last statement we don't like.
and we started talking about the state of the certification industry and how like information security certs are really just a huge money grab and how frustrating that actually is. And he asked me, he said, what is the one problem that your students have that if you could just wave a magic wand and fix it, what would it be? And I said the VM. There's too many people that just do not have the ability to run a virtual machine at all. And a lot of the classes, you set it up and it's like, it's a VM, 64 gigs of memory or 32 gigs of memory running multiple VMs and all of this garbage. And it's just really, really, really frustrating for a ton of people, especially if they're trying to get involved in computer security and they just can't run the VMs. And the next day he came and he gave me his business card and he said, I've got free VMs for your students. Get in contact with me after the conference and I will make it happen. And he did. So no charge to us at all, just absolutely phenomenal. And I'll share more information. His name's Arnie Bellini, owns Bellini Capital, and he's the person that founded ConnectWise. So all kinds of really cool research. So we're a huge fan of everything that he's doing for the community. And if you could go find him, if somebody can find his LinkedIn profile. If people could go on LinkedIn and say thanks to Arnie, I would really appreciate it. All right, so we've got this VM now. I'm going to set up two separate instances. One is going to be set up to do the detect engineering. And then the other one is going to be the one that's going to have the malware running in it. So I'm becoming root here. And now we're going to start by running the commands. The first thing we're going to do is we're going to make node backpipe p. So I told you that everything in Linux and Unix is a file. So what we're doing is we're creating a FIFO device file. What the hell is a FIFO device file? A FIFO device file is a first in, first out file and allows us to transfer data. And that is in fact Arnie right there. That is the LinkedIn profile for Arnie. So let me post that, see if I can get it a little bit bigger for the, there you go. So if you can go on LinkedIn and say thanks to Arnie, I would really appreciate it because he's making this stuff possible for us as well. No, let's go ahead and flood him with love. That's what it's all about here, right? So we're creating this FIFO device file, and I'll talk more about what this is doing in just a little bit with receiving data, handing it into the netcat command, piping it back into the bash script on the computer system. The P means FIFO file and the name is backpipe. So we're creating a special device file with the name of backpipe and the P denotes what type of device file it actually is. Then we create this nightmare here. And this particular nightmare is if it makes your head bend a little bit, that's okay. You can try to run it through explain shell. And you can say like, what does this command do? So if I go to explain shell like this, and I put in the command, it'll explain to you what it is. So before a command is executed, input may be redirected using a special notation interpreted by the shell. Redirection might also be able to use open and close files for the current shell execution environment. The following redirection operators proceed and append anywhere with a simple command that may follow a command. Redirections are processed in the order in which they appear from left to right, redirecting the input. That's self-explanatory. Okay. So explain shell might be kind of difficult. All right. So let's give up on the explain shell thing and let's do the John shell explanation. How's that? All right. So I'm going to go ahead and run this and let me explain what actually is happening with this in a way that is a little bit easier to understand from a pedagogical perspective, because I think that's good. The first thing is we have bin bash. This is literally just an invocation of a shell. That's it. The shell and the command prompt that I'm running here, like this right here, is bash. Now it's kind of weird. I'm using bash to invoke bash, but we're running bash in a different way. So just kind of sit with me on that. We're executing the bash shell. All right, now we have this 0. Okay, so a little bit of background on what these numbers mean. In bash, we have 0, 1, and 2. Input, output, and error. All right. So 0 is denoted by input, or input is denoted by 0. 1 is denoted by output. Okay. 2 is errors. Not always errors. It's not always something broke, but a lot of times error is just messages from an application that it doesn't want to put into the stream in the stream. Now we're running this backpipe here, but I want you to notice that the arrow is pointing the wrong direction. All right. So like the way I described it to my kid a long time ago, to my daughter, I was like, honey, I want you to think of this as like an alligator mouth, right? It's the alligator mouth. Chomp, 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 chomp. It's going to eat the data from the backpipe and it's going to put it into input. And notice the arrow is pointing this way. It's on this side of the backpipe. So it's going to put it into the input into bash. Now that's kind of weird because the way that we read is left to right, right? Like we go left to right. That's just how we read in Western societies. Many Western societies, we read left to right. And we assume that process execution will be left to right. But this backpipe allows us to put the data in the opposite direction, right? So the arrow is pointing the way the data is going to go, and it's going to put it into standard input into bin bash. Does everyone understand that? I just want to make sure that it kind of makes sense to everybody. All right. Okay, awesome. Now, this next thing is a pipe. If we have any output, it's automatically going to be piped into netcat. This is weird because it allows that data to flow back and forth. Okay, so I want you to think of waves. The data can flow through the netcat connection, but the data can also flow through bash. And the data can come out of bash through netcat, and it can go through netcat and go to bash. It can go back and forth. I sway with the wind. Resolution slipping away again, right through my fingers back into my heart where it's out of reach and it's in the dark. All right, so we're moving this data back and forth, back and forth. All right. Now, netcat executes, and it's literally a netcat listener. It's literally just a listener on port 2222. Now, watch what happens. If I connect to that netcat listener and I run a command, let me split my tab. Okay. If I connect to that netcat listener right here, like this, and I go netcat 127.0.0.1 on port 2222, watch what happens. I make that connection. And if I run a command, okay, if I run a command at that point, it's going to take that command, the output of that command, and it's going to put it into 1, which is standard output, all right? That standard output is going to go into backpipe. This is weird, but you need to understand this. How many backpipes are there in this command that I'm running right here? How many backpipes are there? There are exactly 1 backpipe. Nope, just 1 backpipe. We reference it twice. And we know that because we only created one backpipe file. See up here, we did that make node backpipe P. We only created one device file. We're invoking that, not bagpipe. It's a backpipe. Oh God. It's a backpipe. So what happens is as soon as that data enters this backpipe, it looks like on this side, it is also here because it's in the exact same file. All right. So as soon as that data hits the backpipe sends it into standard input into bin bash. All right. Where bin bash executes the command. All right. Now the output of bin bash comes back through. It ignores this because it's pointing in the wrong direction. So that only allows that backpipe to come in that direction. So now if I type ID, it goes through the netcat listener, goes to standard output, gets put into backpipe, gets put into bash, bash executes it, and feeds it right back out to the netcat listener. If I do who am I, like that, it's going to take that from netcat here on the listener, and it's going to put it into standard output, put it into backpipe. Backpipe's going to shoot it into bash. Bash is going to kick out the output back in to the netcat listener. All right. Now, if this seems difficult to you, two quick things. First quick thing is, damn right it's hard. Look, the people that came up with this were like researchers at Dartmouth. They were George Bakos and Bill Stearns and Chris Brenton. Chris Brenton may or may not have been supplying the beer that weekend, but these are three of the smartest people I know in Linux and Unix. And it took them an entire weekend and 2 6-packs of beer to come up with this entire thing. All right. So I'm not going to tell you that this is easy and everybody that knows Linux, like I said, three of the smartest people I know, hands down, came up with this. That being said, the other thing that you need to look at is whenever you're looking at it, one, you have this little arrow. The arrow is pointing the direction it needs to go. When the data is going the opposite direction, it ignores that arrow and it just goes right to the pipe. The other thing to remember is the backpipe is like a magical teleportation device, a TARDIS, is, if you will, time and relative dimensions in space, that allows you to move things from the right side of the equation to the left side of the equation. All right, so that's our malware. So our computer is infected. All right. All right. So now it's infected. How do we actually find the source of the infection? So what I would do now is, since we've done all of that, I'm going to start with LSOF -I, and I'm going to open up and look at all the open INET connections on the system. So you can see here, I have a connection from myself to myself on port 2222, right? So this is the backdoor of interest for me. Right? So I want to drill in on this process ID here. So I can do LSOF space minus lowercase p, because I want to investigate that process ID. And I'm going to put in 264. And now it's going to show me every single open file associated with this process. So it says, this is the root directory. This is the current root directory. This is the binary that's executing. These are all the shared object library files that are running. It also has a pipe. The pipe is located in the root backpipe file. It has access to a terminal and it has TCP. So what this is telling me is that this particular piece of malware or suspected malware on the system has access to a network connection, has access to a terminal, is using a backpipe, and it has an open network connection with another system. That's a lot. But wait, there's more. So I have this process ID, this 264. I can CD into the proc file system. All right. And I can CD into that process ID, that 264 process ID, and I can extract the executable directly out of memory. Look, I can do strings and then run it against the exe, because in the proc directory, it loads, it basically allows us to access what is the executable that is loaded directly in memory. And we can pull out the strings that are printable strings associated with that executable as well. So now let me try piping that through less real quick. Let's do that. And let's see if there's any information about what this executable is. So I can look at the executable. I can see all of the like code reference in the comments and what are the different libraries that it's using, glibc, format strings that are being invoked. What other information will we have? Oh, now we have errors. So inside of the executable, it has errors that it could get back. Could not create Unix socket, failed. Unix connect abandoned, failed. Set IP, I now know it has networking capability. Bind failed, connection to. These are all errors, but look at what we have here. Inside of the executable in memory, it shows you the name of the executable and usage information associated with this executable. So let me kind of put this towards some real malware. There's a lot of people that spend a tremendous amount of time doing Ghidra and reverse engineering malware and trying to go through it. I've actually just done this trick a number of times and like, here's what this malware does. And people are like, how the hell did you get that? I'm like, I found the man page for it in memory. Like, it's that easy most of the time. And yeah, and if this still feels slightly out of reach for you, you have the ability to come back and rewatch the video and do this lab again so it makes sense. But all of this is kind of neat. At least I think so, right? There's just a bunch that we can do to do this type of reverse engineering on it. All right, so that's it for the instructional portion of the day. I've only got 10 minutes for Ask Me Anything, but now's the time, folks. What questions do you have for me? Anything to do with life, the universe, everything? As if there's one thing the world needs, it's a middle-aged white dude giving his opinion on the internet. What kind of things should we be doing if we want to work with BHIS? I would say the first thing is be working in cyber ranges. Try Hack Me, oh God, I just completely blanked out the other one. But also Meta CTF. We have our own cyber range. Cyber ranges are huge. For the upcoming CIS mentorship program, is it okay if you can't exempt? I think it's recorded. That's another instructor. That's Mr. Kevin Johnson that'll be doing that. But yes, the first day of that cyber, a lot of you don't know this, but it's Kevin Johnson's birthday on the first day for that CISSP mentorship training. So be sure to wish him happy birthday. Yep, you got to do the labs. You got to do the labs again and again and again. Got to. Do I remember everything you teach all the time? No, I don't. As a matter of fact, if you take a look at my watch and my heart status, my heart rate is right now at 59. So my heart rate, if I can get it in there, is usually at about 54 when I teach. In fact, it gets so low that my watch thinks I'm sleeping. So most of the time when I'm teaching, I'm mentally completely and utterly disengaged because I've done this so many times. So one of the things that's really, really cool is whenever students engage with me and ask me more questions on Discord. That's one of the reasons why I love Discord so much. Yes, try Hack Me. What is honeyport.sh? Come to the cyber deception class and find out as well. Will you cover QUIC over UDP? So QUIC is a multi-homed protocol. So whenever you're looking at QUIC and also SCTP, but you have these protocols that instead of point to point, like many of your streaming things on like, Netflix and stuff, is one IP address to your system. When you're using QUIC or using SCTP, what you're doing is multi-home. So there can be multiple nodes where you're distributing the load across multiple different systems. It's like load balancing built into the protocol itself as well. Oh, Wild West Hackin' Fest in Denver, it's coming. It's going to be awesome. We're right downtown at the Hilton. If you get a chance, you should check it out. It's pretty cool. I would like it if you all could come. But no, we love Deadwood, but we've sold out in Deadwood the past 2 years. And we have a ton of people that are like, dude, it is 2 hops to get to Deadwood. We aren't getting rid of Deadwood. We're going to keep Deadwood because Deadwood is going to be more awesome than Denver. I'm sorry. It just is. It's a small town. We take over the entire town. The town is a small gambling town that has no idea what the hell hit it because no one gambles. Like hackers don't gamble other than like poker and blackjack and some things like that. But I love it because this town ain't never going to be the same. It's very cool. We got more questions. Sorry, going through. Yeah, talking about SANS being expensive, it is. And SANS is awesome. Like, my definition of success for you all is you get jobs that pay for SANS certifications. That's my goal. If you can get to that point, you have arrived. You are successful in this industry. So please check it out. Watching from YouTube, are we still able to register and pay as you can for the rest of this course? What's funny? I don't think we have any way for you to give us money, like after the class has started.
No, we do. We do.
Now? Okay.
We do.
Get them a link. Get them a link.
It's
We can
still
share that up.
open.
Thank you. You can get it out there. We didn't for a long time because we truly suck at this capitalism thing. We are not good at it at all. So Megan will get the link. All right, there we go.
Yes, I'll post the link.
How can I shine during interviews? Be nice, be kind, be curious. Currently a D for analyst, but I wanted to get the title of engineer. What I focus on to get there, go to the 5-year plan because that'll get you what you need to go. Are we going to go into best practice and handle when you discover malware? No, really, honestly, we're going to be focusing on like backdoors and breaches. Like these are the tools that are at your disposal, and how you use them and stack them is going to be up to you, Elliot. Oh man, there's so many questions coming in. Oh my God. There we go. I did catch up. Yeah, and we are creating, do you guys want to see the questions? You guys want to see the multiple guest questions that are coming? Let me see if I can pull some up real quick. Just give me a second. Oh my God. Hey, Megan, could we get a link for the anti-siphon anti-cast? The Hal Pomerantz one?
Yep.
Hal is like one of the people I've learned from, who's just awesome. You need to check him out.
They'll be in class, but it is recorded, so they can go back and listen to it.
So this might be cheating. There's going to be over 1,000 questions, but we're certainly going through right now and we're building up. We're currently at over 500 questions for this class and for the intro to security class, but there is going to be the anti-siphon core certification that will be coming up here shortly. Just letting you know it's real and it's spectacular. So it is in fact coming. I'm guessing we'll probably be going live within the next 45 to 60 days. Might be Wild West Hacking Fest. We go live with it as well. Oh, look, my email. So there we go. So it is going to be happening. I'm really super excited about it. And really it's a little bit of background why I'm doing this is I hate multiple choice certifications like a lot. I mean, I really despise them. And it was one of my things that I constantly was grinding an axe at the SANS Institute when I was teaching there. I think multiple guest questions are awful. There's a long history of multiple guest questions, IQ tests, and how they really don't judge your skills that well, especially whenever they're applicable to like real world scenarios. And the military found this out before World War I. They wanted to come up with multiple guest questions to gauge IQ, to figure out who should be an officer and who shouldn't. And they quickly found out that that didn't work. And they kept doing it anyway. So we're kind of stuck with these things, which I think is a huge pain in the ass on that. But the point is, I hate them. I wish they would all just die. So the way I'm going to do that is I'm going to create a multiple choice certification. Stick with me. I know that sounds weird if I'm like, I hate this thing, so I'm going to do this thing. There you go. But what is actually going to happen is it's going to be pay what you can. You pay whatever you want for the certification. And the reason why is you look at a lot of these people that charge with like $400 to $1,000 for a multiple choice test. like, what the hell do you think they're doing in the background? Do you think they're walking around with clipboards and like white lab jackets and like, they're, oh, is this the qualitative or quantitative for this particular test question? And how does this actually, oh, well, now we need to come up with a program that automatically gives them a more difficult question before they come in. No, that's not how it's working. It's usually strung together by a bunch of volunteers getting barely over minimum wage to create these questions. And then again, there's like the investment people that like are off in their freaking yachts. They're like, oh, boat, and all that. So I hate them. So I'm creating one. And we're going to create one for the core skills, and maybe we'll create more certifications. But there are going to be some differences. One, it'll be a multiple choice test, of course, but everyone that gets certified will have to submit a write-up for 3 CTF challenges in PDF or doc format where someone can see your work effort. So they can look at this document and they can say, yes, this person did a good write-up. They have good writing skills. They have good communication skills. They have excellent ability to call out multiple screenshots of what they actually did, because I think that's one of the things that's missing. Am I going to go and grade everyone's papers? Hell no. SANS did that, and it was a bad idea, and they decided not to do it. And I got to see that fire firsthand. If you want to put up garbage work, whenever employers look at it and it's garbage work, that's on you. That is a reflection of you. If we find out there's plagiarism, we will nuke you from having a certification. But no, I'm not going to be the document police trying to look at all of these things as well. Yeah, I can give you some CTF write-up examples. Tomorrow we'll have some more on that. The t-shirt is coming. They're creating a discount code for you all. I only think I have about 100 and some shirts, so it is going to be limited. It is going to be first come, first serves out there. No, I'm not going to accept previous write-ups, because it's going to be 3 CTF challenges. It's going to be like, download this memory file and do a write-up of what you discovered on it. What is the malware and things like that. So those write-ups will be there. We may do a plagiarism check like as it's submitted, because there's some plugins that we can get that'll do that. But that'll be down the line a little bit further out there as well. But it's really, really cool. But we're trying to do this. What keeps me coming back for fueling my passion in cybersecurity, Andrew, I'm going to be honest with you. I like this scene. I like my little pond. I like Anti-Siphon. I like our Discord server. The overall security industry, I think, is a festering crap hole at the moment. It's pretty much driven by a huge amount of money and VC and private equity funding. And you're constantly seeing things that, oh, this particular tool is best of breed. This one is going to be a game changer in the world of computer security, and blah, 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 and all kinds of garbage out there. And it drains me. Like going to Black Hat, going to going to Black Hat, going to RSA, going to a lot of these conferences, and seeing like the amount of money that's being spilt in it and how much yelling there is really nauseating and exhausting to me. The money is just tiring. So with all of that we're doing here is we're really just kind of creating our own effing scene. And I'll talk more about Henry Rollins tomorrow, but it's one of those things that I think it's incredibly important for us to create communities. And that's what we're trying to do here with the training that we are doing and Discord and all of our stuff. We're really trying to create a sense of community. And there's other people that are out there that are doing it too, but we need to create. No, I don't think the salespeople won, right? I don't think they did. There's a lot of community, and there's a lot of just necessity around what we are doing. And there's a bunch of people that are doing similar things. It's just a lot of those people, they have lots of money behind them, so they can get advertising dollars associated with it. We can only do so many pay what you can classes. We can only do so many pay what you can classes. Like when we do pay what you can, we barely break even with what we do, but that's kind of not the point. But we'll talk more about that as we get closer to the end of the class. All right, so with that, we're out of here. Everybody, thank you so much. I'll see you bright and early tomorrow morning. Come ready to rock and roll.
Just to let everybody know, we're going to be starting an hour later. We won't be doing the full hour of pre-show. So it'll be right around 12 Eastern time that we will start the actual class. All right. Have a good evening, everybody. Ryan, you can go ahead and kill it with fire.